still doesn't run, but I think we are at the end of the presentation anyways. And maybe the transfer switch, that's the one I mentioned. There will be 2 transfer switches. The current one that is available until probably March next year has about half a second of transfer time. There will be a new transfer switch, which is called 200E. That will have a 20 millisecond transfer time, so it's almost instantly. You have the 200 breaker on the input. There's the split phase transformer that you can also have your 120 to 40 in a backup case. And you have the generator input. It doesn't have to be a diesel. It can be pretty much anything, a gas generator, natural gas, propane, or even your truck. And it supports multiple modes. The focus, I would say, is typically on-grid, because most of those hybrid systems are designed as primarily a grid-tied system with a temporary backup function, versus an off-grid inverter is designed from a different perspective. It's typically always off-grid with a temporary function of a backup generator to recharge and get you over a few days of bad weather. In this case, the off-grid inverter needs to provide more peak power because all the loads and all the starts need to come from that inverter, versus a normal grid-tie inverter that is more transformerless. As I mentioned earlier, there are some issues with some manufacturers when it comes to peak power on those transformerless, are not necessarily designed for the highest possible peak power for inrush current. Yeah. Same topic, you use the charge and everything, generator control based on SOC. And that's pretty much the setup of the standard system. You have your solar plus the hybrid inverter. The transfer switch is in between the service entrance and your load panel. And you may or may not have the generator connected to, plus, of course, the battery system connected to the inverter directly.
Maybe worth pointing out about that there's only one type of inverter, not a hybrid.
Exactly, and maybe one part that is different to some other vendors, Danny just mentioned it, Growbot only sells hybrid inverters. There's no one version that is solar only and another version that is hybrid. If you buy, or when you buy it, XH, it will always have the full functionality. There's no update key and update code where you pay another $2,000 and all of a sudden it has the hybrid functionality like some other manufacturers. It comes as a hybrid, no matter if you use it or not, which will allow you then to go back to the customer if you want to upsell to a battery system in the future. Very good. Looks like lunch is here soon. Thanks, guys.
You are very tall.
Oh.
Okay, yeah, as Alex mentioned, also thank you for the presentation. Thank you for filling in for Zach. We are going to be taking a short break now. Lunch is being served at the moment, so feel free to indulge and just have fun. And as we're going to come back at 1, but as we're having lunch, I'd kind of like to invite you to check out our project over there by Hannah Energy. So this is the showcase project of Power Rack. The Power Rack addresses residential, small commercial, and off-grid needs. It offers reliable backup power and off-grid performance, and it integrates really well with solar and storage configurations. So it functions very much so like a standalone backup power system. So I highly encourage you guys to speak with Hannah Energy and check it out as we're having lunch. And we'll resume at 1. Thank you so much.
Thank you.
Thank you.
Just one quick question regarding a Growbot stuff, right? Do you guys are doing design for them, or sharing? Do they have some kind of package stuff or courses?
What do you mean? Design for customer systems? Typically not. No.
I mean, like based on the information included in the presentation, that's a lot of information you have to go back and forth with the homeowner, right? Like
Not necessarily,
critical, like
no.
backup.
That's the big thing. So if you have a critical load panel, that is challenging because the electrician needs to switch and move circuits from the main panel to the critical load panel. And that's very challenging because the customer doesn't really know, do I need this circuit or do I not need this circuit? Very difficult. So most manufacturers,
That's a whole
they go
house.
home backup,
Doesn't matter.
and then you go the opposite way. You say, okay, which ones do I not want? That's much easier because you know, okay, this is the breaker for the hot tub, don't need it. This is the breaker for the dryer, also don't need it. And this way, the customer has light and function in the entire house, and not on the big loads versus the opposite. It's much easier.
Because
So-
I was wondering, that's a lot of conversation, and even like between the installer and the homeowner, and then
in 2011, we expanded to the downstream a little bit. We started to produce cells, modules, racking, and container solutions. In 2011, 12, 13, 14, that time, actually, energy storage was still a very, very new concept for the market. Plus, there was a very small scale production. The cost was so high. It was a very, very tough time for Pylon Tech to promote energy storage. And at that time, solar was still a hot market, and no inverter company would like to spend some time, some resources to do the compatible testing with us, right? They all busy for solar PV, and we kind of walking to every inverter manufacturer, talking to them. This is the future. We should work together to achieve some better solution for the market. And finally, we got accepted by Victron. Victron was our first partner in energy storage solution, but of course, starting from the off-grid system, because off-grid, at least they have to use batteries. That time was using lead acid, so just replace it with high-cost lithium batteries. But luckily, we still have some clients willing to try these new technologies. So after a few years, after 5 years, we spend all those time to developing and making our residential products getting more mature, and also especially for the BMS. BMS is a software, only time can fix the software bugs. So we already spent 5 years to do the debugging for the software. Right now, our BMS in the market has the longest history, already past the bugging time. And in 2018, we reached 1 gigawatt-hour BSS shipment globally, 95% for residential solutions. You can imagine how many systems are that. In 2019, we expanded another 1.5 gigawatt-hour capacity for batteries. And in 2019, that time solar went down, and a lot of investors from solar industry starting to look at new technologies. And that time, more and more people are starting to talk about energy storage. Actually, thanks to Tesla, they promoted a Powerwall in 2016, 2017. So more and more people are starting to know energy storage starting from the residential. And so a lot of investors looking at this energy storage industry, they found Pylon Tech already in the market for 10 years. And they did a lot of due diligence on our company, talking with our clients, checking the products, some feedback from the market. So all good, check. So make us successfully IPO in the end of 2020. And in 2021, we ranked as number 2 residential supplier. In last year, we made a lot of achievements. We got selected by Morgan Stanley Capital International Index on their list. And also, we reached 1 million systems shipment. And at the end of the year, we ranked as number 1 residential system supplier by IHS. It's based on the shipping volumes. And since last year, we also focus on ESG, talking about the long-term strategy of the company development. And this year, we spent all those efforts to localize our footprint. We built offices globally, and we also have signed some third-party partners, and Frankensolar as our official service partner in Canadian market too. Doesn't it work? Super here? Yeah.
Just want to keep number 1 there.
Huh? Okay.
It was lagging a bit.
Oh, okay. So here is some efforts we put for the ESG. ESG, environmental, social responsibility, and governance. And just last year, we obtained 86 new patents for developing new products on the battery, and also make the battery cycle life is longer, make the temperature control better, and also increase the density for the batteries. Pylontech, actually, we are the first company got a sodium cells certificate. That will be the next generation for our batteries. I believe end of next year, we will start to do the mass production of the sodium cells. And last year, we also put all solar panels on the rooftop of our factory. Just now, Rocky mentioned that we should put solar panels on the rooftop, which is showed on the video, which was blank, nothing on the top. So last year we already did that and reduced 11% carbon emissions. And because we make ESG as our to do the self-governance, and all of our new packages will be plastic-free, only do with some recycled materials. It's costly, but it was for the sustainable future. Here is the overview of Pylontech. We have 4 manufacturers in China. Our headquarters is in Shanghai, and we have 4 manufacturers in China, Yangzhou and Anhui. These 2 manufacturing base, we have cell production. So the total capacity of these 2 cell production has 13.5 gigawatt-hour capacity. And this year, we also built a new module manufacturing base in Italy. That manufacturing base is especially for CNI products, CNI solutions. And this year, we also built a few headquarters in different regions. North America, we built the office in Dallas. And we also built branches in Netherlands, Germany, Spain, UK, Italy. And Australia and Japan in the process to get in the new office there. We also have our own technical service. We also have the third party, like strategic partners as the service center in different regions. I think that one has okay. Pylontech is one of a few companies has the real vertical manufacturing chain. We have our own cells, even cell material from our own shareholder. We have our own BMS, putting BMS and the cells together to make battery modules, racking, and container solutions. What's that benefit to our partners for the end users? So firstly, we don't have any supply chain issue. Even during COVID, we keep delivering and we don't change the price. That's the important, because the lithium mining materials price went up by 10 times. But because of the raw material in our own hand, so in order to build our long-term relationship with our partners, we honor whatever we signed. And secondly, because all those cells from the same quality control system, so we commit to our partners, it's the quality of our cells, of our battery, is traceable and reliable. And thirdly, which is more important for the whole industry, we do have the capability to do the backward compatible. For example, today, Frankensolar, you sold a lot of US 3000C. Maybe a few years later, clients thinking about use more US 5000, right? So if one US 1000C broken, if at that time you don't have the stock of US 3000C, you just use US 5000. So US 3000C and US 5000 could mix in one system. So this is the value of the backward compatibility. So this is for residential segment. Even for commercial segment, we also have the same philosophy. We always make the new version gonna do the backward compatible with the older version. So this gives us give our partners has the long-term business opportunities too. This is a third-party testing report from ITP from Australia. They bought the batteries from the market randomly. Bought PylonTech batteries since 2017, along with Alpha, Simplify, BYD, LG, Tesla Power. They did the testing, whole year testing for PylonTech batteries is 5 years. So you can see during the 5 years testing, we didn't have any issue at all. This really gave us confidence to say that we do have reliability. And based on our data, the failure rate, of course, manufacturer should have failure rate as a manufacturer, right? Our failure rate is 0.15%. In the industry, I believe we have the lowest failure rate. And this page from the same testing report. So every day they do 3 cycles, do the actual practice. So after 2,000 and 2,500 cycles, you see PylonTech still has the best status of the battery. The blue line is PylonTech. So we already shipped products to more than 80 countries. The product has been complied to different criteria in different regions. We have very strong R&D team. We have more than 200 people in our R&D team. Actually, in headquarters, we have 2 buildings. One is especially for administration. One is especially for R&D, for sales, for new materials, for modules, for the integrated solutions. And last year, we built over 4,000 square meters, which is a UL 1973 witness testing lab. So that means for this, we can test in our own lab. They just send people come to do the witness and get the stamp. This is the product suite. Because we have our own cells and own BMS, so it's easy for us to make a different format. For the cells, we majorly have 4 types, 37 amp hour, 50 amp hour, 100 amp hour, and 245 amp hour. So we kind of like play with Lego with different cells and plus BMS to make a different format from the 12 watts, 48 watts, 400 watts, 1000 watts, 1500 watts systems. And Frankensolar also has the 12 watts, that 12 watts 100 amp hour battery. Based on our knowledge, that is the best 12 watts product in the market. It has a heating film built in. It could do 4-in parallel connection, 4-in serial connection. And for the 48 watts, mostly for residential, we have rack mounted. We also have stackable. So depends on whatever clients like, they can choose. They have different options. For residential, we also have high voltage solutions, which is also stackable. And the cabinets, which is our new design, especially for CNI solutions. And we also can provide a solution for grid, like utility scales, which is container solution. We could build everything including PCS in the container, or just build the DC block container plus the PCS. We do have high compatibility with different inverters. We can compatible with Solis, Victron, SMA, Coastal, GoWi, Solarc. I think we also compatible with Hoymiles for the new products for residential too, 48 volts. And if you scan this QR code, you can get the fully compatible list. We have compatible more than 40. So here I'm gonna show you we have different solutions for with the UL 9540 certificate for the market. The rack mounted, we have US 3000C. One module is a 3.55 kilowatt hour, and this is a 48 watts battery. And US 5000C, same format, but the with a little bit higher capacity, 4.8 kilowatt hour per module. And we also have outdoor cabinet to carry those batteries. This cabinet could put 6 US 3000 C or 4 US 5000. Then with cabinet, with batteries, we could work with different inverter. So right now, which we already got a UL 9540 certificate, is we have two solutions for US rack-mounted batteries. One is a Solarc 5K and a 50K. The other one is Schneider, which is here in this cabinet, in HANA Energy Systems. In this cabinet, everyone has interest, you can check it out. For Paleo, we also has, this is a stackable. The name is Paleo. Each module is a 5 kilowatt hour. So we also have UL 9540 certificate with Solarc 5K and 15K. So this module is newly released since last year, and end of last year. It's a 0.8 C rate and 5.12 kilowatt hour per module. It's a very slim batteries. So I think someone wants to put it in the garage. This could be the good option because only the width, the thickness is only 6.5 inch thickness. So it's kind of like stick on the wall. Doesn't affect too much for the car parking. So this battery could do wall mounted and ground mounted. For wall mounted, you can stack 3 together, make it 15 kilowatt hours. For ground mount, you can make 4 per stack, make it 20 kilowatt hour per stack. And for the whole system, maximum we can have 20 modules per system with Paleo, with this product. So this is for the high voltage, residential high voltage solutions. Each module is 3.55 kilowatt hour, and each stack we can have up to 7 modules, so 24 kilowatt hour per stack. And for one system, we can maximally have 6 stacks per system, and work with solid S6 hybrid inverter. So here just say this is like a scalability. You can choose from 3, 4, 5, 6, 7, depends on customer, whatever they want. So easy to do the sizing. For Solid S6 inverter, we do have some recommendations because this battery is half C rating. So we recommend for 7.6K, we use at least 14 kilowatt hours, which is 4 modules. And 10K, we recommend with 21 kilowatt hour. 11K, we recommend with 7 modules, which is 25 kilowatt hours. We also can provide the batteries for CNI solutions, CNI projects for different scenarios, all those. Why doesn't it show? Okay, so it could be used for self-consumption, demand charge, microgrid, EV charging station, backup, peak shaving, off-grid, V2G frequency support, pair with wind, solar, different scenarios. For commercial products, we have same philosophy. All those batteries is modular design. So you can easy to do the different size. Each module we have 2 modules for high voltage commercial products. One is 4.74 kilowatt hour, and the new one M5 is 15.68 kilowatt hour per module. For commercial, we guarantee the cycle life is 7,000. For residential, the cycle life is 8,000. Residential is a smaller system. We have a little bit longer cycle life, but still also 10 years warranty. And for commercial projects, normally we come with 3-level BMS structure. Why it's always self-moving? Each module we built in with BMS, BM unit. And each racking we have, why doesn't it show? Oh, okay, so each racking we also have the BMS, and for the whole cabinet or the container solutions, we have master BMS to control it. This is the product we are under the process to get a UL certificate. In next 2 months, we will get the UL 9540 certificate. So this cabinet, if we do fully mounted, it is about 100 kilowatt hour per cabinet. Of course, you can do less. We certified with 4 configurations. One is with 14 modules, with 10 modules, with 14 modules, with 20 modules, with 21 modules. So when you try to promote this product, you always remember these kind of certified configurations. Because if you just do 9 modules or 13 modules, it's not your 9540 certificate. So just remember that. This work with Solar 30K and 60K. And next year, when other brand has new release products, we also gonna compatible with different inverters too. For Optimus, the Optimus outdoor cabinet, we have 3 types actually. So right now we are certifying the first one with M1C, 100 kilowatt hour per cabinet. And we are also able to do with the M5, which is a new product. Per cabinet, we can have 300 kilowatt hours. This has 2 options. One option is making 1,000 watts. The other option, we can have 1,500 watts. Just make it as 1 string or 2 strings. So make a different voltage. This is the battery module of M5, which is a new product. Each module has 15.36 kilowatt hour, and also with the main controller on the bottom of the rack. We also can provide the container solutions. We can have a 10-feet container with 1 megawatt hour, 20-feet container with 2 megawatt hour or 3 megawatt hour. So the difference between these 2 solutions, both of them are 20-feet container, but this second one has the PCS built in the container. The third one has a PCS outside of the container, so give some more capacity for batteries. Here is just some projects we did with our batteries for residential, commercial projects. Okay, so here is just say why Pylon Tech. We are vertical integrated manufacturer. We control those resources from the beginning to the end. And we already in the market for 14 years. It's already built a long-term relationship with our partners, building the trust with our partners. We already been proved by different markets, more than 80 countries, more than 10 years already. Kind of like the first batch of the battery already passed the warranty period, 10 years warranty. And we do have backward compatibility. We can do easy to do the customized solutions. And right now, before, I believe it was hard to work with us, especially the technical support, right? So always I have to talk with the headquarters, so 12 hours difference, so time make us so difficult. Right now we have hired a local engineer, local technical support. He is based in Dallas, so he is our first technical support, but we're gonna hire more, so we will give you more support from locally. We don't have any time issues. And yes, that's us. Thank you.
Any questions?
Any questions? the mountain bracket, yes. Yeah. If no more questions, maybe later on you can just check our products in that cabinet. Okay. 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 All right. Okay. Thank you, QQ, for the presentation. Is this thing on? Okay, it is. I just need to talk really directly into it. Okay. Next up, we will be talking about residential and commercial rooftop with Leon, the sales manager at Longi. Leon has over 4 years in the solar industry, and his experience includes system design and project management and sales in the Canadian market. This presentation is the gateway to designing the optimal or residential or commercial rooftop system using a variety of Longi modules. We'll be covering site analysis, system sizing, array configuration, and electrical design characteristics, such as mounting methods for various roof structures and ground mount. We'll also be taking a detailed look into module specifications and characteristics. So everyone, please welcome Leon. Just get this really close to you.
Sure. Just clip it right here. Actually, that's fine. No.
You might just want to hold it in your hand, maybe.
Okay, better. So thank you for the introduction. Actually, anything she mentioned in the introduction won't be included in this presentation. I just figured out this morning because the presentation they sent us is not about system designing. But I do have some sort of knowledge about system designing while I was working on the installer side. So feel free to toss any questions to me and don't roast me too hard. I'll just get into my presentation here. So Longi Solar, show of a hand who used our products before? Good. Not everybody? No? I'm expecting like a larger number of hands up. Yeah. So we've been in the industry for over 23 years. We actually started in 2000, and at the very beginning, Longi Solar is a wafer manufacturer. And all of a sudden, we think, why don't we just make our own module? So then we started to be the top, the module manufacturer as well. So here shows some numbers we did in 2022. For example, we are top 1 global module shipment in 2022. That's 19% of the market share, 35% of the wafer shipment in 2022, and that's 35% global market share. Longi Solar dedicated their revenue in the R&D sector really well. So as you can see, out of the 2.3 billion net profit in 2022, we actually spent 1.1 billion on our R&D investment. We believe that with more advanced technology that can bring not only benefits to us as the manufacturer, but also to every single person who was involved through this chain of renewable energy. So in the solar value chain, we focus on the wafer as our bread and butter, to the cells and to the eventual module. Some of the numbers I've mentioned already. Sorry. Oh, point the computer. Perfect. So we're the leading performance in the. This is the number shows like about everything about our company. For example, #1 shipment in 2022. We are tier 1 manufacturer for I don't know how many consecutive years, but currently we're still tier 1. We are a AAA bankability rating. Now, what does that bankability translate to everybody else who's in the industry? So not only that represents that Longi has a really healthy cash flow, that obviously the banks are willing to lend their money to us, but also we are one of the companies, we are one of the few companies who actually been existing longer than how much they're carrying for their warranties. So basically, we're here to take care of you for any warranty claims. If anything happens, you will always have someone to reach out to have your things, have your modules replaced. Third-party validations, I won't get into that too far because I have no idea what that is. So over the years, from 2015, as you can see, the efficiencies for modules, the cost for modules going from 12.1 cents going all the way down to 0.048 cents in 2021. That's because of the nonstop innovating in the technology. That's thanks to all the money LONGi Solar spent in R&D over the years to bring us to where we are right now with the technology and with the reduced price.
Can you go back to that slide? What's that 0.48 cents? That's for wafer cost, or what is dollar per kilowatt hour?
Yeah, it's dollar per kilowatt hour.
On the entire
project.
module?
On a project.
On a project.
And here's our customers around the world. We've been have our footprint in over 85 countries, and we have 5,000 plus global customers. Frankensolar, right there. Some of our products on the market right now are the HIMO 5 product with 72 cell, 54 cell, and 66 cells. 72 cells, we have monofacial and bifacial that's targeting CNI projects. 54 cell, that's the new size that we came up when we are announcing this HIMO 5 module type. The 54 cell actually is getting more and more popular over the last year. That people are adapting to this 54 cell size, and people really like it because it's lighter, it has the all black option, and it's basically easier for installers to putting that onto the roof. 66 cells, that's more flexible for various applications that you can use it for residential, you can use it for commercial, whatever you like to do with it. That's one of the options we're offering at the moment as well. And now I want to talk a little more about the wafer size evolution, because that's where we start our business. The wafer size evolution went from the initial, I think a couple years ago it was the M6. Now we're into the M10 years for the standardized of the wafer. Now the benefits of standardize this wafer is that, number one, when the wafer size is standardized, the dimensions for modules are standardized too. So across the industry, people are all having the similar size of the modules. And what does that mean for solar installers? It means that you don't have to, all the balance of the system are standardized as well. For example, your racking, for example, your clamping, for example, your inverters. Basically everything involves into a solar installation will be standardized. So that's what we're focused on, to make sure that we are growing with the trend of this industry, but also we're leading this trend to make sure that hopefully everybody else follows as well. Module packing, as you can see, the top, the frame, the top glass, and the encapsulation on the inside, top and bottom of the wafers. There's the back sheet, and it's in a different order, but yeah, that's the front glass. For the bifacial modules, instead of the black sheet, you will actually have another back glass at either 2 millimeters or 1.6 millimeters, depends on the fire rating at the jurisdiction, and the weight definitely will be a little higher, but in return, you will actually have the benefits of bifacial modules have anywhere between, I'll say 5% to 15% of increase in production. So I mentioned about the wafer size standardization. Now this is what I also talked about, the module size standardization. Like I said, when we are standardizing the size of the wafers, the module size are standardized as well. And that's related to your rackings, your inverters, your clampings, and everything. So yeah, a little more on that topic, that with the standardized size, the balance of material is basically you're saving 5 cents Chinese yuan per watt, and the logistic cost will be cheaper as well. Bifacial technology. So LONGi is one of the first companies that introduced the bifacial technology into the Canadian market. People at the very beginning did not believe in how much the bifacial modules can bring in revenue, but it's to test that the 8% to 25%, depends on where you are, that's a significant of increase in productions over the years, that when you're thinking that increase in 25 years, and that's a huge benefit for investors, for homeowners, for whoever owning the system. Now, as I mentioned, our current module type is called the HIMO 5, which is the 5 series. Now we're into the 7 series. The 7 series, over the years, we went from the mono technology to mono PERC, to the bifacial, to the larger size 12, the wafer, the M10 wafers, and now we're into the cell tech. Basically, what it translates into the module, I'll just go into the next page here. So this shows that with the HIMO 5, which is the top HIMO 7, which is the TOPCon technology, LONGi's TOPCon technology compares to the industry standard has a 0.6% of advantage in production. The 0.6% in production means that 0.6% increase in generation performance. It means that 0.5% higher the life cycle power generation and 2% less on the life cycle failure rates. I'm going to go into a little on the system design. You have your roof, you have your panel, and you have your sun. A couple of things that's really important to the Canadian market is that, number one, where you're at, right? We're on the northern part of the world, and your tilt angle is something you want to be very sensitive about. Are you installing your ground mount at 25 degrees? Are you installing to 30 degrees, 35 degrees? That's one of the key things installers look at when they're looking for ground mount installation. Now, this is a map showing that the radiance all across the nation. I'm from Calgary, very fortunate. We're in a place that has a lot of sun exposure, so the ROI for residential solar installations are pretty good with all the incentives going on at the moment. Now, tilt angle. That's something I just mentioned. You want to make sure, because you don't have too much of an option if you're installing your system flashing to the roof. But if you're installing to the ground mount, I think 35 degrees is kind of the ideal tilt angle in this part of the world, and that's what most people are installing their system to. Aurora, our strategic partner, I think most people see this company use their software. I used it before myself for system designing. It's a very quick tool, and you can have access to basically all the products available on the market, put that into the system. It's just something that's very beneficial for the installers as well. Canadian Electrical Code. I did graduate as an engineering, but I didn't study any of the electrical code, so I won't embarrass myself to get into this. But we do take certifications very seriously. We want to make sure that every single product we are pushing through to the market are certified and are safe to install. Now, in the Canadian market, what we have to face is extreme weathers. Snow load is something people always keep in mind. When I was on the installer side, the number one question I get is, what if it snows? Like, how much of a solar production will you get in the winter? Will your solar panel actually hold the weight of the snow? So that's actually something people cares about, and that's something we have done a lot of testing on to make sure that not only our product is competitive in pricing in the aesthetic and also in the actual weather constraints. Hail resistance. This is the number 2 question I get asked for. When I was in Calgary, we get a lot of hail damages. People ask me, well, solar modules are glasses. how would your glass hold the damage from the hail resistance? So LONGi has done series of studies and testings on the hailstone damages impacting especially people see a lot more hail damage in the U.S. We don't see much I don't think people see a lot in Vancouver, but in Calgary it is a real concern, and we have done testings against it, and we want to make sure that the glass we're using are thick enough to resist all those hail damages. And there's some numbers and graphs showing the testing we've done with the strong hail resistance we have with our modules. Now, another question people ask is, why can't you just design your module with thicker glass? Well, the thicker glass relates to a heavier weight. Then the heavier weight will be harder for people to hoist it up using a ladder, especially when it's windy, especially when you're on a two-story building, or you're onto like a two-story building with a walkout on the back, then that's something even harder. Besides the glass are very fragile, the wafer cells are fragile as well. So what have we done to protect not only the glass, but also what's underneath the glass? There isn't a standardized testing against those wafers across the industry. And the need for an accurate cell quality test standard is something people are looking for, but currently there isn't a real good methods that people look at, and all the solar manufacturers does those testings. So LONGi's approach is that we have developed our own testing methods that to make sure that not only the glass, but also the wafers are capable of handling all the weight. So as you can see on the left, figure 1 shows a simplified 4-point bending cell test setup diagram. That basically shows we're putting weights in the middle and point loads, 2 point loads on the side to make sure that the wafers are in good quality of holding the weights. And as you see, the graph shows at what point it becomes a failed product and what point it's a good product. And by doing this test, what we are able to achieve is that based on the deformation characteristic of the cell, we are studying this and avoiding using those failed materials into making the actual modules. So we do this test early on to make sure that we have an extremely low failing rate due to this issue. High temperature. When the ambient temperature is about 30 degrees, and when you are doing installation on the roof, that's probably adding another 20 degrees. And when the solar system is in operation, that adds another probably 15, 20 degrees. So your modules are actually running at 70 degrees Celsius. Now, module high operating temperatures in the field are over 85 degrees Celsius. That's a little more conservative, maybe causing doubt failures. What we have done is we throw the modules in the oven. We make sure that can sit with the heat of 100 degrees Celsius. That if it can stand the temperature of 100 degrees, then I think 85 should be easy to handle. By screening out unqualified diodes at raw material selection stage, we reduce the thermal failure risk, and we reduce the power production loss and the fire hazards. And this is a more comprehensive view of our testing standards to different part of the work. For example, the PV glass, the junction box, the cells. For the PV box, for example, we do the thermal runaway standard to further reduce hot spot failure. For the cells and EVAs, the 4-point bending standard I just showed you guys, and the co-extrusion POE standards. Product advantage. So with all the testings I mentioned above, that set us different from other manufacturers. That's the barrier that made us a tier 1 manufacturer, and that's why people put their trust into our product, into our modules. So our product advantage is that not only we used all those testings to make sure that our products will last over 25 years, last over our warranty, the performance warranty period, but also we used the various of technologies to reduce for example, the light induced degradation, and to make sure the end users, the developers or the investors at the very end actually gets their money worth. Another slide showing the bifacial gains from modules. I don't need to go into that too much. Actually, one of the interesting points I didn't think of before is that in the winter, the bifacial modules actually gains more than it is in the summer, because in the winter, when there's snow on the ground, in Alberta, not in Vancouver, in Alberta, when there's snow on the ground, when the sun shines on the ground, it reflects more sunlight back to the back end of the modules, and actually gains more in the summer compared to in the winter compared to it is in the summer. We have diverse installation methods. We can do short side clamping, long side clamping, 4-point clamping. You can do tilt on the roof, on the ground, and you can do east-west dual tilt installations. We are compatible with most of the racking manufacturers, and we have been working closely with all the racking manufacturers to make sure that their clamping methods are compatible with our module as well. So people have a more variety of choice of rackings on the market. And we are compatible with mainstream inverters. For example, whole mile and string inverters, Fronius. We want to make sure that by choosing our module, it does not limit the installers or the end users to a specific kind of inverter or other systems or balance of materials. You can basically use our modules with everyone else's product. The module trending. HIMO 5s is at 550 watts at the moment. The HIMO 7 are going to the 610 watts. And our next version of the technology, I don't know how much it will go, but that's something in the development right now. Even though the HIMO 7 is not ready to buy, not ready for purchase in the Canadian market yet, but LONGi has already think forward and putting their money into R&D for the next generation product already. A little summary: product design, material selection, the product planning, the reliability testing, production manufacturing, outdoor power generation, empirical validations. All these are the things that LONGi values, and these are because we care about the end users, because we care about our product, that made us where we are today. Maximizing the revenues. For example, we talk about reducing the logistic cost. The reliability of our products not only reducing our time and overhead cost for warranties, but also reduce the cost for installers, for distributors to go through all those claim reports. Reducing the material cost, reducing the labor cost, and reliable power generation overall. Everybody talks about the AI right now, so we actually adapted AI into our manufacturing process as well. That will help us to reduce our cost on the labors, reduce our cost on inspection errors, and it will actually increase the efficiency by 25%. And we are manufacturing in the US right now. Our manufacturer is, I think it will start manufacturing in Q1 2024. The product right now is for US only, but when the needs goes up, when the capacity goes up, we'll be able to serve the Canadian market as well with our US product. And that's it. Any questions? Smaller panels as in
The smaller sizes,
like the
certain
60.
markets, like Vancouver or cities with their smaller roofs, it's not really like bigger houses, like the big houses, but it's not always it doesn't work.
So it goes back to the technology itself. The different size of modules are designed that way because of the different size of the wafers. Now the wafer size keeps going up, which is a benefit because the wafer size going up, increasing the efficiencies of the modules, increasing the wattage size of each module. Now, by having a higher voltage size, I think that's put a benefit on the end users to be able to install more system. But I do understand your concern that smaller roofs has.
Houses, like I design stuff all the time. Like, you can get, can't even get bigger panel. You can even get sometimes 5 kilowatts on it. Or a smaller panel, you can stack them and you can fill up the space. It depends on the house,
Yeah.
especially smaller houses, depending on the design.
I think that's not only relates to the technology, but also relates to the capital cost. Like how much cost we need to put into manufacturing a smaller module compared to putting into a larger module. And does that benefits us or does that benefits the end users? Does that benefits like everybody in this chain of sales, right? So I think with the larger size, and that's the trend. Unfortunately, that is the trend that with the larger wafers will come with the larger modules. There's 72 cell modules and there are 78 modules on the market, 78 cell modules on the market as well, which is huge. So I think that is unfortunately the trend of the solar module growing, but that's actually a benefit from the advanced in the technology. So. Yeah.
I think overall the market is always asking for higher wattage panels, right? And lower cost. It's a price driven market, and
Yeah.
larger panels, shipping costs, all those things kind of come together. And again, it's in our interest to have solar panels that are less expensive overall to get higher adoption rate. And yes, at times will cause, you cannot put as many panels on a specific roof, but you probably can put more wattage overall on a roof than you could have like with what we used to have with like 250 watt modules, right? That were a little smaller, but the efficiency overall is going up, right? Like we're at like 21% efficient panels at the moment.
Yeah.
The TopCon is going to be even higher, right?
2027, and I think LONGi just announced like the latest efficiency which is the highest record is 33% efficiency. So
That's on a test module.
that's a test rate, but still when they actually put into production, that can translate into a even higher, not even higher, but like a little bit lower than the actual testing.
Is it still TopCon or?
No, that will be the HJT.
You guys are gonna have to get you guys' own trucks to unload them. The tailgates, they're only.
What panel are you using right now?
No, but for example, like they're, Longies, like the big ones, like we did some 505s, they barely come off of.
Yeah, but they have
Tailgates.
405s, for example, right?
Yeah.
And that's going to be
90
continued.
inches.
They will have
Oh, yeah.
430s.
445s, 440, 445s.
Which are
That's the.
similar size 2D 405s, so those are meant for
Yep.
residential applications, right? Those are the 54 cells. They're continuing to produce that.
Yeah, that's why we keep a couple options on the market for our products. That's
Well, I've seen them come off trucks pretty hard, like they have basically different companies that can't get them off the truck.
Especially the 550s, right?
Yeah, I understand.
Yeah.
Yeah. No, that's I remember when I was with the installers, I actually spent like 3 hours driving a forklift. That's the first time I'm driving a forklift, trying to unload a full container of modules. That wasn't pretty because we didn't have like a dock or anything. Like it wasn't a pretty picture, but yeah, transportation, that's something we value as well. We want to make sure that not only that it's easier to offload, easier to unload, but also it's safe to be transported. Because the module itself, with all the consideration we have, it is overall a pretty fragile piece of equipment in the entire solar system. So we have to make sure that the transportation is safe and making sure that it does not break during the transportation. Any other questions?
What's the timeline on the heterojunction type panels? You kind of hinted at that.
I think that could be something we can look at late 2025 or 2026. I don't have a confirmed date on that because we're still pushing for the top count. But yeah, that is the technology in development. That's will be the trending.
Is Longi planning on getting into like anything else, like solar glass, or there's all sorts of other?
Yeah, we do have a building integrated photovoltaic products that's in China because it will be very limited to local building codes, will be very limited to certifications, will be limited to weather constraints. Can those be adapted into the Canadian market? We don't know at the moment, but those are the things.
The company, you should look them up. Matrix, MITREX.
Yep, yep. I do aware of Matrix, and they're doing pretty like decent work, and you know they're in the Ontario's, right? They've done some pretty cool projects. That's definitely something people are looking into in the trend. But overall, that's a very high-end product, I would say. From my experience, I think that's a very high-end product. Even say solar shingles, right? Tesla has this new product for shingles. You can just put it onto your roof and act as a
Demand for them, or, there's a demand for that stuff.
Yeah, there is the demand, but like how many people really willing to spend all that money to have a similar output eventually with having solar modules installed instead, right? And I'm not no expert on BIPV products, but when you're looking at investing into, basically I see solar as an investment for anyone, like for residential owners it's an investment. So you have to look into what is the ROI for your system? How many years you can get your money back? Are those systems gonna last for 25 years, or are those systems lasting for 12 years? Are they just for the good looking? Are they gonna eventually pay back for all the electricity bills you're saving? Right, so there's a deeper conversation to it, and right now I think a lot of BIPV projects being built are with a very good incentives from the government, or push in the industry to help these technologies to be evolved and more advanced. So that's kind of how it goes. But the answer is yes. Longi we do have a department focusing on the BIPVs, and we want to eventually introduce this product into the North Americas too. Serving the customer.
A lot of that stuff is also for marketing reasons, right? Like a bank would have it in their building.
Exactly.
It stakes out, right? So you get the marketing portion. It's not necessarily, at the moment at least, something that makes a whole bunch of financial sense, right? It'll be very hard to have it ever be mainstream from that sense of things. There's some downsides, right?
Yeah.
Same with the solar shingles, right? Solar shingles have a lot of downsides, a lot of connections, small area, less efficient. Building integrated doesn't allow for much airflow, so there's less efficiency there. So there's a whole bunch of downsides to it. But of course, there's also advantages, right?
Yeah, and so the Canadian solar industry, from my point of view, it didn't really grow that aggressively until like the government introducing all sort of incentives and programs and helping the greener homes, the free loan, interest-free loans, right? All those programs has been introduced that create this urge in the need for solar. And I'm sure once there is more money from the government putting into the renewable energies, let's say for BIPV targeted projects, then that when the need goes up, then I think that's not a better time, but like that's where you can see a lot of BIPV products on the market. I'm sure not only Longi is looking into this before. We do install a few manufacturers for our own solar shingle type of a roofing in the on top of the manufacturers, but those are for like pilot projects, and what's the actual paybacks, or economically does it make sense? That's a deeper study. Yeah. Is that all the questions? Well, thank you for your time.
Thank you.
Oh, I'm sorry.
Thank you, Leon, for the presentation. So we will be having our final presentation of the daytime. We are ahead of schedule. So today we will be talking as our final presentation on string inverters. String inverters are often misconstrued as being difficult to design for or work with, but this presentation is going to attempt to dispel the notions of those and try to help installers get the most out of their string inverters. So our presenter Harsha is the technical support manager for solar energy at Fronius Canada. He's right over there. He has a background in electromechanical product design, power systems, power electronics, and renewable energy. So today, he will be able to walk us through this topic. So please welcome Harsha.
Oh, yeah.
It's good to see you. Thanks. Do I need this? Do I still need this? Do you want to use it? Not really, no. No. Okay, well, good afternoon, and I hope people are still awake. So my name is Harsha, and I work as the technical support manager for solar energy products at Fronius Canada. Now, by a show of hands, how many of you guys are installers or electricians here? Okay, and do you guys have any experience with string inverters? You do? Have you used them before? Good, so, how did it work for you? So who installed it, you or him?
No, he's inside.
You can't decide, okay.
Go ahead, Ryan, he installed it. Go ahead. No, it's you, bro.
Okay, anyway, that's fine. I was just kind of like, trying to pike everybody's interest. So the basic idea is we are Fronius, and we are a family-owned business. We were, and we still are. The business actually started, nothing's happening? Okay, so it was started by Gunther Fronius. Gunther Fronius is the guy who's standing with his back to the truck there in 1945 in Pettenbach, that's in Austria. And he started it in his garage, and we actually didn't start out by making inverters. What he did start by doing was making an automotive battery car charger. So you can see that huge thing that he's got right by him. So that used to take AC power supply from the grid and convert it into DC, and that was being used to charge batteries. Now, Fronius's primary expertise is in power electronics to convert power from AC to DC and vice versa. So the oldest of our business units is in automotive battery chargers. So we have a business arm that's called Perfect Charging. So that's the oldest one. And what we did was we leveraged our expertise in power electronics to make us the next product line, which was basically welding machines. So Fronius, although the biggest business arm for Fronius is solar, we are better known for our welding simply because welding apparently happens to be in your face, whereas solar tends to be out of the picture, usually on the roof or somewhere in your basement. So nobody usually gets to see the solar infrastructure. Okay, so now we've got 3 business units, but of the 3 business units in Canada, what we are primarily invested in are solar energy and welding. Now we do also sell chargers here, but the chargers that we sell are not CSA certified because we do not have a big enough volume to justify recertifying those products for our market here. But a lot of the high-end dealerships, they do require their dealerships to use Fronius equipment, even in Canada, even though they aren't CSA certified. So that's where we end up selling those chargers too. Now, we're Canadian. We've been in the market since 2009, although 2007. Although when we did start out here, we started off with only the welding arm, not for the solar arm. And then we had the Ontario FIT programs get into the picture, and that's when Fronius officially entered Canada and opened a solar business unit. And one of the requirements for the Ontario FIT program, should your equipment be qualified to participate there, was you needed to have local assembly. So we actually had a local assembly line where we used to put together inverters in Mississauga in our offices. But that requirement was taken out of the Ontario FIT contracts in 2016. So since then, we didn't need to invest that. So we moved the assembly line to the States and then ultimately turned into a repair center instead of an assembly line. Now, that was our first batch of inverters that were put together in Canada. And at that time, we had transformer-based inverters. And that is the IG Plus, or the original series. Then we came up with the next line, which you can see on the picture to the left. It looks a little different, not the one on that side, but to the right of that picture. And those were the SIMO inverters, or snap inverters, as we call them, and they are transformer-less inverters. Now, I'm sure you guys are familiar with these terms here. Can somebody tell me what is the difference between a transformer-based inverter and a transformer-less inverter? Yeah, and how does that affect the way you install? I beg your pardon? That is one way, but not when I said install, I'm talking about install the entire system, not just the inverter. because having a transformer-based or a transformer-less inverter will affect the way the rest of the system is installed as well. How? I? Not so much. Yes and no, but that's not the primary reason. Does it go up, go down? Sorry? Oh, that's true, but there's one very important factor you got to keep in mind. Now, when you talk about solar installations, sorry? It is. It's grounding, exactly. And the reason I wanted to bring that up is oftentimes when people talk about cost, when it comes to solar installations, you're looking at upfront cost, but not long-term cost. Because when was the last time somebody came and told you that this is going to be the cost of operations and maintenance over the course of your system, which you expect to last you 20 years? Nobody ever talks about that. Now, why does that become important when you come into the equation where you have transformer-based versus transformer-less? When you had transformer-based inverters, the inverters actually had a transformer inside them. Transformers is extra weight, clunky, more material. But they came with an inherent advantage that the PV panel side of it, the solar array, was not floating. You actually had one pole coming from the PV array bonded to ground. Okay? In itself, that doesn't mean anything, but it kind of buys you a sort of safety margin. Where is that safety margin you're getting? No? Okay, so the idea is because you've bonded one pole of the array to the ground, your risk for catastrophic failure when it came to ground faults because of isolation failure or insulation failure on the DC side, that gets minimized when you have a transformer-based inverter. So that's the inherent trade-off. A transformer-based inverter is less prone to catastrophic ground failure due to insulation loss on the DC side than compared to a transformer-less inverter. But the disadvantage is it's very heavy. Typically, they operate at lower voltages, okay? And efficiency isn't or could be a little higher than it is currently with transformer-based inverters. But the good thing is transformer-based inverters are no longer made or very rarely made. Simply, yeah? They are transformer-less. Very few manufacturers in the business will make something with a transformer simply because your margins are already, like blade thin. They'll go even lower. Okay. So almost nobody in the inverter manufacturer market now does make transformer-based inverters. Okay, and so that comes with it, like an inherent saving, which is basically material and cost. But the flip side is you really need to be very careful on how you build the DC side of the system, because that DC side of the system now cannot be grounded. It has to float. Okay? We all know it's floating always. Nobody ever intentionally creates a ground fault. So where does the ground fault come into the picture from? What is a ground fault on a DC, on the DC side of an inverter or a solar system or a solar installation? Okay, what does your inverter do? Okay, and so you've got electricity going out from your PV panels. They go into the inverter. They get converted into AC, and they go back to the grid, right? Now, let's say that you had a failure of insulation or isolation failure somewhere on the DC side. Now, what is going to happen to the electricity? Instead of going through the inverter, it'll find itself alternate paths. What alternate paths could it find? Let's assume you build your solar installation near like a primary school, and kids have a habit of chucking stones on the roofs, right? And so if you did chuck a stone and broke a PV panel, what happens? Okay, I shattered the glass on a PV panel or a PV module, as it should be called, and it rained. What happens?
Stops working.
It got grounded effectively, all right? Basically, your electricity that is being produced found itself alternate paths. Now, the risk when it comes to going with string inverters or micro inverters or whatever other kind of inverter that you have is how many panels are you actually connected to when it comes from the inverter's perspective. So assume you've got a positive pole coming into the inverter and another negative pole, and you're looking through those two poles into the PV array, all right? And so now if you were to take the example of a microinverter, you've only got one PV panel or one PV module connected to a single microinverter or a single optimizer. So if I were to blow the glass on that particular PV module or nick the wires coming from that PV module going into one particular inverter, the electricity will find itself an alternate path and usually will close that path through the inverter's neutral, should you have one, and it'll fry the neutral there. So which means that you having a failure on a PV panel or a PV module elsewhere in the system or a nicked wire or something like so elsewhere in the system completely unrelated to the inverter will end up damaging the inverter, okay? And so now let's assume that you've got one panel which was broken and you had two conductors coming from said one panel and you have potential failure points where those connectors come from the panel or from the PV panel itself because the glass broke. Now let's assume that you go with a central inverter, a 250 kilowatt inverter. Okay, let's assume it's got 12 MPPTs, and each MPPT is capable of taking you 6 streams. And let's assume it's a 1500 volt inverter, not a 1000 volt inverter, which means, and let's assume this is in BC again, so maybe your winter temperature is only -5, which means now I can go up to 22 panels in series on each string. So that's 6 strings per MPPT. Let's say I've got 12 MPPTs. How many panels do you have now? You don't have to be accurate, but that's a lot of connections, right? That's a lot of connections.
1,000 volt here. A lot.
I said 1500 volts, so it's even more connections. All right, so that's that many connections, that many failure points, that many PV modules you can break, that many places you can have human error when people are putting things together, that many places your installer can take a call while crimping the last MC4 connector and not do a good job of it. Okay, so you see the number of failure points for you to blow one inverter will start going up the bigger and bigger you go on the inverter size. The flip side is you can also go to smaller and smaller, except your PV panels go where? Where do you mount your PV panels? Okay, and which is the harshest condition you can have electronics in? Yeah. So the flip side is on one side, you're going smaller and smaller on the inverter side. It buys you certain advantages, but it does come at significant trade-offs. In similar fashion, you can go bigger and bigger on the inverter size. It'll buy you certain advantages, but again, it's a trade-off. So where do you draw the line? Do you want to stick with a micro, an optimizer? You want to go with a string inverter? You want to go with a big string inverter, a small central inverter, or a big central inverter, or I don't know, what else? So how do you make this call?
Depends on the roof.
Sorry?
It really depends on the roof. You have to
Exactly.
know if it's
Yeah.
site. You need to know the views, shading.
Exactly.
You got a crazy ass roof,
Yeah.
you're not going to install furnace.
Well, you could. It depends on the roof again, right? And so, no, it also, there's a few things you've got to keep in mind is the more experience you've got with solar, especially being an installer, the easier this decision is to make for you. The second thing is, whatever technology you go with has to be qualified by your experience and the site conditions, all right? So if you've got a gabled roof, right? Let's say it's a mullion window kind of roof, and you've got 100 different pitches and azimuths. I like to call those chandelier roofs, simply because you see a chandelier, it's got glittery glass pieces and how many faces it's got. You'll find roofs with that many faces. So I call them chandelier roofs. Now, if you come up to me and say, I want to put a furnace on a chandelier roof, I'll say, don't put a furnace, simply because it doesn't make any sense. So for a roof with that many different orientations and angles and pitches and azimuths, you're better off going with a micro inverter or an optimizer with a string inverter, rather than going direct with a string inverter. But if you had a simpler roof, or you have ways of mitigating shading and other such instances, let's assume that you've got a really nice roof, but you've got a massive copse of trees around you. But let's assume that for whatever reason, that tree doesn't actually cause you any shading in the season where you would expect to see most of your production. Would you still go with an optimizer on that roof? Yeah. So again, your choice of devices, your choice of whatever you want to build your system with has to be quantified by your experience and your knowledge of the site. Okay. Now, keeping that in mind, I'm just going to go off into the presentation here, and towards the end, I'll kind of draw you into this picture again, where you kind of separate those issues between different inverter technologies. Now, one of the biggest advantages to any sort of manufacturer, however good your products might be, is the benefit of having support, and more so if you have local support. All right. Because you could make the best of devices on the market, but if you weren't able to teach the installer to make the most of said device, you might as well not sell him that device. Okay? Which is why Fronies believes a lot in training and support, not just before we sell you something, but after we sell it to you as well, simply because you have to remember that a lot of these systems are built to last you in excess of 10, 15, or even 20 years. Which means that were you to face any problems in the course of the 10, 15, or 20 years, you as an installer might at most be responsible for the installation for 2 years after install. But what happens after the 2-year mark? Are you going to look after it? No. So if there was a mistake that was, something like, it was an installation error, let's say. It happened within the 2-year mark, except the results of whatever issues you got when at the time of install, we will start seeing that after the 2-year mark. But by that time, you are no longer in the picture, which means that I'll have an irate customer literally blowing his head off and trying to contact Fronies support to find out why it isn't working. So with all of that in mind, what we'd like to do is invest a lot of time, effort in training people. Not all of it is going to be fruitful. Not every training that we give out will bring in sales. But irrespective of that, we still go ahead and do it simply because we do know that over the course of those 10 or 15 years, if there were to be any problems faced, it's not usually the installer who takes the rap for it, it's the manufacturer who takes the rap for it. So we'll go over and beyond to make sure that you do it the right way when you do, perform the installation. And we'll also give you adequate training to be able to kind of guide you through any post-installation processes you might get to experience within the first 2 or 3 years. Okay? And I'll show you that in a few slides from now, and you'll understand why. And the biggest advantage to having local support, especially when it comes to solar, is because solar is so strongly driven by the weather. If you didn't know the local climate of the weather, you might as well not support that person. Okay? Because I'll give you this. Like, it's a I'm sure you've seen Fronius inverters. The housing is built from plastic, which is why we are very aggressive in enforcing this rule that you are not to use power tools on plastic. Now, for somebody in a place where it doesn't freeze, that makes it's irrelevant. But for us, where it does freeze, it becomes a huge factor. Why? Sorry? Plastic, crack.
Yeah.
Why? Why is it a problem here in Canada and not elsewhere?
When it gets colder, the plastic behavior is different.
It's not so much the plastic behavior. Basically, any sort of material, you crack the material in winter. Once you get ice inside, ice expands. Once you go below 4C, and it'll grow the crack. So, once you get the crack growing on any material installed outdoors in Canada, that crack will grow. Okay, a few hard frosts, by the end of the winter, it won't be a crack anymore. It'll be a complete split. Okay, so which is why it becomes very important to have somebody support you who actually knows the local climate, because this isn't even something that somebody who's from a tropical place would even be able to imagine, simply because they've never seen snow or ice in forever. Right? So you always want to make sure that whoever's helping you or providing you support or training actually understands their product and also the place or the conditions into which your product is going to be installed. Now, one of the visions that we do have at Fronius is 24 hours of sun, and I know we spoke about this earlier. We actually don't yet have a hybrid inverter on the market in Canada, or in the US for that matter, but in the rest of the world, we do actually have a hybrid inverter that is being sold right now. Okay, now this is one of the earliest of systems which was installed in 2011. Okay, these were all IG plus based systems. And you can see that the systems we've had monitoring from back then, and since we provide free monitoring, a lot of people make use of this to make a comparison of their system's output over the course of a decade. Now you can see that typically on a system that has never been washed or cleaned, you would expect for the year-on-year drop of accumulated energy to go up, except you're actually not seeing a year-on-year drop. You're seeing almost the same. If any, it's getting better. Why? How does your system give you more energy as the years go on, despite you not even washing the solar panels?
Well, usually the PV is going to deteriorate, and then the inverter is not going to lose power, so it kind of flickers off.
You're telling me that the source has less power, so you're actually doing better?
Repeat the question?
It's the oversize.
Sorry?
It's the oversize.
Well, it was just as oversized even at the outset.
Just the weather changes.
I beg your pardon?
Weather changes?
Yes and no, but not entirely. It's more like, I was just harping about the effort we put into making sure that you do it the right way. What we actually started noticing was if we were actually able to better support you within the first 2 or 3 years and get you to fix your problems within those 2 or 3 years, after that time, you would face less problems and your system output actually goes up. It doesn't go down, despite not cleaning the panels, and nobody cleans their solar panels, definitely not in Southern Ontario, I can tell you. Okay, so this is the key place where you'll start realizing, not from you guys as an installer perspective, but also as your end customers, keeping their interest in mind as well, that if we are actually able to support you and make you guys, execute a really good project and do it the right way, you'll actually see that to start with, you have very few errors. And if you did have any errors, because we've guided you all along, we'll actually be able to find out anything from those systems by looking at their monitoring profile within the course of the first 2 or 3 years. And if you get those 2 issues sorted out, you'll see that going beyond that, you have fairly good performance outside of catastrophic weather events and things like that. Okay. So now, when it comes to the product offering, we only make string inverters. Fronius does not believe in module-level power electronics, okay? Because we do believe that the electronics, if kept in a place where the weather or the environment is more comfortable, will last you a lot longer, simply because the remaining portions of the system, which play a massive role in how a solar system is put together outside of the inverter, will decide how well the inverter performs. But you also have to remember that the inverter is the only smart component of the system who can complain should anything go south. But oftentimes, it is taken that if the inverter complains, the problem is with the inverter, not elsewhere. And so the first 2 or 3 years I was telling you about, so within those first 2 or 3 years, as long as the inverter is not already damaged, we usually are able to find you the cause of those problems and get them fixed so that going forward, you will have fewer such issues. Okay? Now, when it comes to the product offering, we've got snap inverters. That's the only thing we make. And snap inverters are called so simply because the inverter that you see here, let's assume that you were working with some other manufacturer, all right? And for whatever reason, the inverter failed, and you had to perform an RMA, or basically exchange the device. You would oftentimes be required to undo all of the wires on the old device, pop in the new one, and redo all of your wire connections on the new one, which is not a requirement in this case, simply because the part of the inverter, that's the actual electronics, can be swung out. The mounting bracket with the wire terminations, et cetera, stays behind, and all you need to do is just pop the replacement electronics onto it. So you save yourself the hassle of taking wires off and redoing your connections, which is why we call it a snap inverter. You just snap the old one off and you snap the new one in. And when it comes to the three-phase, we make the SIMOs for 2 voltages, which are 208 delta three-phase and 480 delta, Y. Okay, we will not make a 600-volt inverter simply because, again, the only market in the world which uses a 600-volt AC inverter, not DC, is Canada. And the cost to make a new design and prove the design over the course of the life cycle to make sure that you're not in the high failure rate of the bathtub curve if you worked in electronics is too high to justify re-engineering a product or even just the front end of the product for such a small market. Okay? And because we have seen in the past that when you try to save time on re-engineering a product for a completely new design, you actually end up increasing the failure rate. So we did not want to be in that situation, so we decided that if you want to use a Fronius product and you do not have grid compatibility, you're better off using a transformer. It'll give you more mileage out of your device than re-engineering this product and giving you something without actually having proved it. Okay, and all of our string inverters, they either come as single MPPT devices or dual MPPT devices. Okay, this is the 480 that I told you about. Now, you can mount these inverters in several different ways. You'll find them mounted all over, every school rooftop in southern Ontario. You can do that, but just make sure that if you're in an area which Lian was talking about earlier, where you can expect a lot of hailstorms, please use a shade cover on them, simply because if you did have a hailstorm and the thing is just punched through, obviously that won't be a warranty claim for you anymore. This is the shade cover, so if you are in a place where you expect to see hail, I don't know, tornadoes, whatnot, you could go with a shade cover, although I'm not sure it'll help you in a tornado. Okay, now this is another thing that oftentimes people will keep harping on about is, oh, you've got shading with one single leaf. Is that going to take your production down by 70%? Now, this issue of maximum power point tracking and shade is a little overblown, simply because when it comes to shade, it's not so cut and dry. Okay, so take the example of an eclipse. We had an eclipse, I don't know, a few weeks or months ago. And when you have an eclipse, you have an area of really hard shade, which is normally called the umbra, where absolutely no light goes through, which is why it's really dark. And then you got a lighter ring of shade around that dark area, which is what we call the penumbra. Now, the penumbra is kind of like a gray zone. Does it let light through? Yes. But is it as good as actually having all light with no shade? No, it isn't. Now, what does that do for us when it comes to maximum power point tracking is, like people assume that shading means, let's assume you've got a 72 cell PV module, and I threw a piece of tarp across 1/4 of that. Now, tarp is effectively opaque. It lets no light through. Except when you talk about real life shading, you rarely ever get opaque shade like that. Because shading could be due to moving trees, rustling leaves, passing clouds, I don't know, maybe there are balloons going up the sky, or maybe it's the shade of your neighboring church spire that moves across the roof as the sun moves across the sky. Now, all of these sorts of shade, they have different characteristics to them. So if you've got really hard shade, like let's assume it's the shadow of that church spire I told you about. So in that situation, absolutely no light's going to get through the church spire, which means you are creating hard shade. And the edge of that hard shade also matters. Like, for example, is your church spire 20 meters from this roof that you expect to see the shade on? Or is it 100 meters? Now, if it were to be 100 meters, it didn't even matter because you're not even in the hard shade region anymore. You're only in the penumbra, which means you likely will not even be affected by any shading issues. Okay, so this is why you always want to make sure that when somebody's trying to sell you the idea of amazing tracking and it's going to minimize shading and things like that, you've got to remember, even if you use the best optimizer or microinverter, it cannot get you the light. It can only adjust what it's getting from the existing panels in a way that it won't pull down the production from adjacent inverters, panels, or whatever else is next to it. But despite all of those efforts, you cannot get that optimizer to get more light on the panel because that is a given. You're not going to change that condition. All right? Now, having that knowledge, you can actually play with how you're going to pick which inverter technology you want to go with on this particular roof based off of what existing knowledge you have about said roof and what prior experience you've got when it comes to designing for such roofs. This is literally what would help you make your choice there. Okay? And when it does come to MPP tracking, or maximum power point tracking as it's called, every inverter manufacturer does maximum power point tracking. Okay? And everybody's algorithm is proprietary. And when you come to algorithms, you're talking about the sweep frequency of the PV panel or the string. So the sweep frequency, like how often do you do it? Okay, and then is that frequency of sweeping fixed, or does it change based on conditions? All of these are different characteristics of different MPP tracking algorithms, and they're all proprietary to each inverter manufacturer, and they're not all that awfully different from one another. Okay, so this is just to show you how MPP tracking works. So you can see that we've got the output in kilowatts or watts on the y-axis, and you got the voltage on the x-axis. Were you to not have any shading, like on the blue curve, which is at 12, without shade, you will have one peak, which is GMPP, which is short for Global Maximum Power Point. Now, were you to have shading, and depending on how you have the shading or the shadow that's being cast across the PV panels, how many PV panels you got in series, how many such strings you've got in parallel, how many cells inside each PV panel, all of that will change how many MPPs you get. Okay? There's a mistake here. It should actually say LMPP and GMPP. So if you have more panels, let's assume this is with 2 panels. If I throw in 3, I could potentially have 2 local maximum power points, which are LMPPs, and 1 global maximum power point, which is GMPP. And the job of the PV algorithm, which is the MPP tracking algorithm, is to sweep across that entire curve, find out all the different local MPPs, compare the energy there, and see which position you want to sit on so that you get the most energy from that particular panel. Okay? But this is at this instant in time for this time of the day. And there is no guarantee that 2 minutes from now, the light's going to stay the same, your shading's changed, or the sun's moved. And if it has, then the curve has to be swept again. So which is why that frequency, the curve sweeping frequency, becomes important, because if your frequency is too slow, like you sweep every 10 minutes, your conditions are completely different. You're still sitting on the point that was optimized for the conditions that were present there at that site 10 minutes ago. But you're still sitting at the same place. It is possible now that the clouds moved, you've got better light, but you're still sitting at a less optimal position. Okay? So these algorithms, like I mentioned, every manufacturer has them, and everybody has fairly close accuracy levels, if you will. And all of them, they're all proprietary. So some people change up the way they do the algorithms. Some people could be using multiple different algorithms together in succession in different hierarchies. You could weigh them and use them in different ways. You could change up the way you sweep the curve depending on the time of the day of the year, or even the temperature even. Okay, now that's all when it comes to the solar panel and the way the brains of the inverter are programmed to handle said solar panel. But outside of that, there are physical limitations when it comes to the hardware itself of every inverter. Okay, so you've got a temperature range up to which you can work. We work up to -40. We've also got, I believe, the northernmost installation of any solar system within Canada. It's in Sax Harbor. It's outdoors. Okay, and again, the same thing. It's NEMA 4X, approximately IP66. And this is the part I was telling you about the snap inverter. You can see here that the part that's actually swinging out is the actual guts of the inverter. That's the electronics. And the part that stays behind is where you've got that terminal block in the middle where you've landed all of your PV wires. So that way, if I do have to exchange the inverter, all I do is swing out the electronics in the front. Your wires, et cetera, stay the same. So you're saving yourself a lot of time and effort when it comes to rewiring stuff. Now, outside of this, a lot of people do assume that if the inverter failed, your only option or solution is to exchange the inverter. So yes and no, all right? The reason being, if you were an installer who's new to Fronius or has no experience with exchanging components inside Fronius, yes, what you made as an assumption is true. You would have to exchange the full inverter. But if you're somebody we worked with for a few years and we've seen the way you work, what we'll do is we will actually invite you over to join this program. There is a cost involved with the program, okay? But the cost itself is not for the training or anything. The cost is only for you to buy parts. The idea being, let's assume that we invited you over, you agreed to it, and you decided to invest a certain amount of money in it. What we'll do is we'll have an in-person 3-day training class where I will train you down to the guts of the inverter, which is basically we take the inverter apart down to the bare bones printed circuit board, and then have you reassemble it together. Okay, so that way you become comfortable in taking the inverter apart and rebuilding it. That's the first part. The second part is we'll also teach you how to troubleshoot the situation, because it's like going to a doctor. Maybe a doctor's a really good surgeon. He knows how to pull things out and put things back together, except he also needs to know why he's pulling certain things out and putting them back together to get you back up and running on your feet. So now you need to know what is it that you need to pull apart and put back together to get this guy running up again. Okay, so that happens in the second day. And the third day is basically, you've got to understand that failure modes of all devices change with age. It's like us, right? So the kinds of health problems we might have when we were a baby or up to 5 years old might not be the kind of health problems you would expect to see when you're 20 years old or 50 years old. So the way you would approach a person who's 20 or 50 when it comes to diagnosing issues is not going to be the same as diagnosing somebody who's 3 years old. So which means that when you are troubleshooting a solar system, the more information you have as to the age of the system and how the upkeep of the system has been through the course of all of that time, the better informed you are to make these decisions as to which printed circuit board you should be pulling out to fix that issue here. Okay? So that is also a part of this training here. And the last part is basically, I did tell you there is a certain amount of investment. Now, typically, were you to have an RMA at a site, you would have 2 truck rolls at the minimum. The first one would be to go to the site, find out what's going on, call it into the manufacturer, give them like a case report or whatever they call it, and then those people, whoever else is on the other side of the phone, will go through all of those notes and come to a decision saying that, let's assume we need to cover this under warranty, and for us to cover this under warranty, this is what needs to be repaired, and if this needs to be repaired, this needs to go out to that person. So once that person receives that, he makes a second truck roll to the site to fix that issue. But we don't want for that to happen in these situations, so what we do is we ask for you to do a survey of the installed base of inverters in the region this person is willing to service, need not necessarily all be installed by him. Okay? If he can get information from other installed inverters in the area, because remember, when like if he's called upon to service a system, you would service a system even if you weren't the one who built it, as long as you get paid for it and you're able to fix the issue, right? So here, that is the premise under which we are working. So we expect for you to purchase kits of 3 inverters completely torn down to the base printed circuit boards and have them with you when you make the site visit. So that way, when you make the site visit and you are able to diagnose the problem, you also have the equipment with you to fix the problem in the same truck roll. Okay? Now, outside of this, we make string inverters. And when we talk about string inverters, we do need to get into the question of rapid shutdown boxes. Rapid shutdown boxes, like you know, we haven't exactly kind of followed suit with what the US guys do, because now they insist that you're supposed to have module level rapid shutdown. We are not yet at that stage in Canada. We are still allowed the freedom of using string level rapid shutdown, which is what we make rapid shutdown boxes for. The only caveat is the rapid shutdown boxes that we make only go up to 600 volts DC. So please make sure that you have taken into account the calculations of open circuit voltages for the lowest site temperatures you expect to see, because if you went over 600, you've toasted a box. Okay, now all said and done, a lot of people are very interested about monitoring. Okay, now I want your perspective on monitoring. What exactly is monitoring useful for? Is it necessary even? Is it beneficial at all?
Module level monitoring is useless, but you need to see what your production is.
Okay, when you say production, are you talking about production from the module or production from the inverter?
From the inverter, what you're getting.
Okay, now there's a reason I phrased that question that way. I'll bring that back.
Is not necessarily what's coming
True.
down.
Well, thank you for that, because I intended for you to bring that up, because I'll bring that into a different question later on. Okay. Now, the biggest advantage to monitoring is a lot of people, especially if you're in a new suburb just freshly built, is you want to have a show and tell session for your homeowners association is what most people like to use it for, but that's the last thing you should be using it for. Okay? Because you have to remember that the roof is the last place anybody ever looks at. Nobody cares what goes on your roof. When was the last time you actually went up and inspected your roof? Does anybody remember? Exactly, which means out of sight, out of mind. That's literally how roofs are treated. Okay, so now imagine you've got a whole bunch of electronics, hardware, and I don't know, 50 grand worth of equipment on the roof. You don't want to worry about what's going on in your roof, especially something that could set fire to your roof if something went terribly wrong. Okay, so ideally what you want to do is make yourself really familiar with your monitoring system and understand how you can use whatever reports, notifications you get from monitoring system to use it as a health monitor for your system. That's what you should actually be using it for, because a lot of the time solar systems are built under the premise that they're maintenance free. Are solar systems maintenance free? They are not. So why do people assume they're maintenance free? Exactly. It's got no moving parts, but that didn't mean it's maintenance free, because everything else is still getting cooked, baked, and frozen up on the roof, which means everything is getting aged. And as systems age or materials age, their integrity gets compromised. If your integrity starts getting compromised, remember I alluded to ground faults earlier? So your charge coming from your PV panels, instead of going down the wires into your inverter, will start finding alternate paths and burning other things in the process. Now, this is a given because you cannot prevent aging, but again, depending on how good your system is or how well put together it is, it'll give you plenty of red flags before it actually goes down the drain. And if you know how to make use of your monitoring, you'll pick up on those red flags and catch them and fix them before they actually become a huge hole in your pocket. Okay, that's what monitoring is supposed to be used for. Okay, oftentimes, unfortunately, that's the last thing it's used for. And one of the things that we do teach people in that, the program that I told you about is to how you can make use of notifications, triggers, and other activities on the monitoring portal to make sure that you can keep an eye on the system. Because if you are able to keep an eye on the system without actually going to the site for the first 2 years, you've actually gained yourself a successful O&M contract with the people that you built the system for. Because you've got to remember, solar systems are usually built to last you 10, 15, or 20 years, and there will be a good requirement for operations and maintenance on these systems over the course of that time. Okay? So the more information you have about your system, it doesn't necessarily have to be a Fronius system. It's the same gospel truth despite any manufacturer, any installer, any PV panel. Okay, now that's the hardware which is required for monitoring. Now, in addition to having hardware, you need to have a source of internet. So we do not provide internet. We thought we could, but then we started seeing that a lot of the tech support calls that came in were telecom tech support calls and not solar calls. So we had to kind of wind that down. And so we do have a platform, though, as long as you're able to get yourself your own internet connection and set it up the right way. These services are actually provided for free. Okay? You need to have your own hardware, your own internet, and if you did set it up the right way, then all of these services are provided for free. And we do have an online monitoring platform and the apps that go with it. The app is also free, so is the platform. Okay? Now, outside of this, if you do have your system on the monitoring portal, you can even go online and register the warranty on your inverters there. Because if you don't register the warranty there, the date of delivery of the inverter from your distributor to you will be taken as the date when the warranty on the device starts. Now, in addition, we do also have weather stations because some people, especially if you go on very big projects over a megawatt, they're very keen on collecting site data instead of relying on weather data from a commercial weather station. Outside of this, we also have a smart meter. Now, this smart meter is not a utility-grade revenue smart meter, so you cannot use it to challenge your utility bills. Okay, but it's more of trying to kind of tell you how much of whatever you produced at your house is meeting your requirement, if it does, or if you're producing more than how much you use at home, over and beyond what you did consume, how much are you exporting to the utility, and at what time of the day. Now, outside of this, I kept harping on training because I keep telling you, you could have the best portfolio of products, but if you didn't teach people to use your products, you might as well not sell those products. So we are very serious about trainings. We invest a lot of time in it and effort. We also offer trainings on demand to people who are using Fronius for the first time. Or if you've got a crew and they need to be retrained or for whatever reason, you can always ask us for a training. And you can always sign up for the newsletter. Okay, now has anybody here worked on retrofits? They're also called repowering projects, which is basically you've got an older PV array with a dead inverter or an inverter that's nearly dying, and you want to pull that out and put in a new inverter there. Okay, so that's what we call repowering or retrofits. Now, there are some thumb rules you should be keeping in mind when you perform retrofits. What are they?
Are the panels certified to 1,000 volt, for example?
Exactly. So the first thing you want to do is anytime you are performing a retrofit is you want to find out the existing documentation, if anybody's actually held on to it, about what codes and standards and whatnot these devices, existing devices which have been installed, are rated for. Okay? Because, for example, if you take the Ontario FIT program, on the DC side again, not the AC side, Hydro 1 would not let you go over 600 volts DC, which means now if I go back and look at a repowering project, of which there's usually several gigawatts worth of it in Ontario, the first thing I will be asking for is for their single line diagram to find out what is the rating on the cabling and the PV panel voltage ratings that they have there, because it is very common to find where people would have used 600 volt panels with 1000 volt cabling or the other way around as well without realizing the error. Okay? You have to remember that now, because it's a repowering project or a retrofit, the system's been out there and it has aged. So although the cable at the outset might have been rated for 600 volts DC, there is no guarantee it is actually good for 600 volts DC even now. Okay? So in all of these cases, you have to do some basic checks before you commit to any project or even offer them a solution when it comes to offering them use this inverter from brand A or that inverter from brand B, you have to make sure that whatever technology the old system was built for, because remember we did speak about transformer-based versus transformer-less. If the older system was transformer-based, okay, you also have to remember that back then there were panels which were being manufactured with only one lead because the frame was the other lead. Have you seen those panels? Or you could see panels where it was a positively grounded PV panel, not a negatively grounded PV panel. They aren't as common, but they did exist. And so it's always very useful to gather that information because you might go up with a project proposal ignoring the fact that that is a grounded PV array, and the inverter you're suggesting as a solution isn't going to make the cut. Okay, so you always want to have this information about any systems that you are performing retrofits on or repowering them on. And one last thing you always want to do is, I told you about insulation failure and isolation tests. You always want to do your isolation tests on any PV panel that you are going to be retrofitting with a newer inverter, and you have to do them under certain weather conditions, all right? The reason being, just because I've got a nicked wire or a broken PV panel does not mean I have a ground fault. You also need for the right conditions to be present, like in terms of moisture, rain, snow, meltwater, to get into those breaks and touch the earth to give you the ground fault. Because if you did perform the test for a ground fault on a dry, sunny day, it'll pass because you've got no contact to the ground. But the moment it rained, you've destroyed an inverter because the test was not performed under the right conditions. So please always make sure that whoever you're hiring to do the test, or if you're doing the test yourself, you are adequately informed that the test that you are performing is actually going to get you a result for the conditions that you are checking for. Okay, because if you do, like I mentioned, a ground fault test on a dry day when the temperature is above 4C, everything's going to pass, except the next day when it rained, everything's going to go up in smoke. So you have to make sure that when you're testing for these conditions, that you ideally want to do them under wet conditions and preferably above 4C temperature. Okay, and outside of this, in terms of our offerings for support, we also have what we call solar online support. Now, I did tell you that the most important thing you could ever ask for from any manufacturer is to have local support. But you also have to remember that local support means that you will not have the convenience of calling somebody at 12 in the night and having somebody answer because we are asleep then, but not necessary that somebody overseas 12 hours away is also asleep. So they could get you an answer, but we can't. So the flip side to that is we also make available these solutions, which is SOS, which is Solar Online Support, wherein if you sign up for an account, it's free. It's like signing up for an email account, and you have the serial number on the inverter that you are troubleshooting, and you pop it in there, and you can put in a few state codes and conditions. It'll actually kind of walk you through a few steps. But again, you've also got to remember that you shouldn't actually be doing this at 12 in the night, simply because first, the conditions don't exist. You should not be troubleshooting a solar system when there is no sun. Okay, that's a given. And so we've got limited time zone support when it comes to our local support that we offer. But to make up for it, we do also offer the option of making appointments. So if you are going to a site that's a few hours away and there's a great risk that you might think you might not get somebody on the phone, you can call in a few days ahead and make us an appointment. Even if it is after hours, somebody will call you instead of you calling and waiting for them. Okay, now outside of this is a slightly new topic, but I did kind of feel compelled to put it in here. How many of you guys use surge protection? You do? What brand do you use? Midnight? Is that on the AC, DC, or comms or all? Which do you use most often?
AC.
Only AC?
No, we've done both. It just depends on.
Okay. Okay, so.
Design of the house,
Yeah. Okay. There's more to it than just yes or no, right? So the one thing that you have to keep in mind is what we have started noticing is a lot of insurance claims come through, and the requirements on a lot of these insurance claims is they want us to know, or they want us to inform them whether this particular installation was protected with surge protective devices, because we have seen a few insurance claims come through and they weren't protected with surge protective devices, and the insurance company denied the claim. Okay, so this is kind of getting to the side where it'll probably become mandated through in the insurance industry rather than code. Okay, but before it gets there, this is something you always want to keep in mind is the yeah.
So on microinverter devices, obviously we put them on the AC side.
Yeah.
With swing inverters, sometimes DC side and sometimes depends on.
See, ideally, it actually depends. So there is a way to predict. I won't say predict. All right. So there are studies where they will map the number of lightning strikes you get per square mile or per square kilometer per year. They are called isochronic maps. So typically what you want to do is look at an isochronic map, and so the closer the lines are spaced on that map, the greater the likelihood that your place will get a lightning strike, in which case you definitely want to use surge protection. And when you do use surge protection, if you see that lightning strike, preferably go on the DC side rather than the AC side.
How much lighting here?
Right?
Lighting here might be on the news.
I know, I'm just telling you, that's how typically it's done.
I know in Alberta.
Yeah.
Whatever. Here is hardly getting lightning.
Okay, is lightning the only way you could get surge?
No, of course not.
What are the other ways?
It's going on and off.
And? So if you have a major blackout, especially if it follows a brownout, there'll usually be a spike. And if you have a spike, it's surge basically, even without lightning, right? So if you're close to a substation and you've got massive capacitor banks that get thrown off suddenly for power factor correction or brought on suddenly for power factor correction, there'll be a massive sag or a swell of the voltage. In all of these situations, all of the electronics connected to that line or the feeder or the substation, especially if they are sources, not loads, okay? Do you understand the difference between sources and loads? So typical house loads, before we got solar or any generators into the picture, they were all loads. You consume power. So the power flow is unidirectional from the utility into the house. And when you take load, your load is effectively code speak for current. It's basically, because the voltage is fixed, you can't really sway the voltage. How much power you get from a fixed voltage, it kind of equates to how much current you're getting from said fixed voltage, right? So now the reason I was kind of bringing that in there is you always want to make sure that when you are consuming power, you draw exactly the amount of current required, which means your load has a certain impedance or a resistance. Okay, so that's device impedance basically. That is true for loads, but when you're a generator, the generator is trying to put power back on the grid. And when you're trying to put power back on the grid, the generator's job is to do it as efficiently as possible. And so there is something called an impedance matching algorithm. And if you look at the utility grid or the hydro grid or whatever we want to call it, it's considered an infinite bus with zero impedance, which means that whatever source that I'm using to make power and put it back on the utility should also have zero impedance, which means it's got very little resistance. So that way I can evacuate all the power I'm making. The flip side to that is, because you've got so little resistance, you automatically become a magnet for all sorts of surge. Okay, so now it means that any sort of generator you've got in the house, it could be, I don't know, a gas, like a Generac or something like that, or an inverter, these are all sources. All sources inherently are required to have very little internal impedance. Because they have very little internal impedance, you are a surge magnet. So which means it becomes even more important to protect yourself against surge. And when you do protect yourself against surge, you have to protect yourself against surge from different sources. You've got to remember that if you remember your CRT TVs with the old antennas, they look like clothes racks. Your PV array is one giant clothes rack. Okay, it's like the old TV antenna. It's waiting to pick up lightning strikes. So anytime you've got a very big PV array connected to an inverter, the bigger the array, the greater the likelihood that you're going to draw something into it because of the mesh of wires you've got. It's like a Faraday cage. So the more protection you will need for that. Okay? And this isn't, again, to say that just because you put in a surge suppressor, you're going to be protected, because even surge protectors, they come in ratings as to how much energy they can absorb because they're sacrificial devices. And if the amount of energy coming down the line or through the surge or whatever that might be is more than the energy rating of this device will go up in flames, and so will the inverter. So you always want to make sure that whatever surge protective device you are putting in place is actually rated to handle the amount of energy you would expect to see come down that line. Sorry?
MNSPD 600.
Yeah, it depends on where. Okay, so this is just a little static about that surge. And again, surge is microseconds. This is, again, common refrain is, how come I didn't see it on my monitoring? Because your monitoring sampling rate is usually in seconds, and this is microseconds. Okay, now this is coming back to the same thing, kind of like a recoup there. Okay, so designing with string inverters is too hard. Is that the case? Has anybody designed with string inverters? I know you've installed them. Have you designed with them? Okay, what do you look for? Does that tell you everything you need to know?
How many MPPTs, how many roof sections,
Yeah.
Startup voltage.
And? Okay, and you also want to make sure that just because you see a solution here, every solution offered there does not mean it's a good solution. Okay, it just means that that solution is feasible and safe for the device, but need not necessarily be the best solution for your application. This is where your what should I say, expertise or experience comes into the picture. Now, the biggest thing that you would expect to see, like Alex was telling us, was we are shortchanged because we get really cold weather, we get really hot weather. Now, if you get really cold weather, you're limited on how long you can go on the strings. If you get really hot weather, you're also limited on how long you can go on the strings, which is why you always want to make sure that when you design the system, you actually have a fair idea as to how the roof is, what is the expected clearance you need to see or you expect to see under the PV panels before the roof surface, because the less clearance you've got there, the less circulation you've got, and the less circulation you've got, the higher the PV panel temperature. So now the PV panel temperature, the hotter it gets, the lower your open circuit voltage and MPP voltage, and the colder it gets, the higher the open circuit voltage and the MPP voltage. So you always want to keep that in mind. And so oftentimes people don't realize that even if your air temperature is only 35 C, your panel could easily be 80 C, okay? And 80 C is plenty hot. So at 80 C, if you went with strings of 3 PV modules in series, you're likely outside of the inverter's operating range, although the design might say it's safe for the inverter. Is it safe for the inverter? Absolutely. Is your inverter going to do anything with it? Absolutely not. Okay? So you always want to make sure it is safe and still useful. Okay? So this is where you come up with it. Now, again, people will ask me, okay, then why didn't they include that here or include this here or whatever? You got to remember that the tool is only a representative device to show you that your voltage, current, and power are within safe limits for the device. There's no way for this tool to know that you got 1/3 of your roof at a different pitch, and another third at a different pitch, and another third at a different pitch. Okay? Or maybe all of the pitches that you just told me about are all facing north, except you're in BC. Would you put panels on the north face of your roof?
You're 4 degrees, or if you're under a 412, sure.
On the north face?
If you're under a 412 pitch.
You expect production only in summer?
No, but if you're under a 412, it's 312, 212, you can put a feasible.
Feasible.
I have more panels going in different directions as well, and just adding some panels in your side.
You could do that. I'll put it this way. If somebody came up to me and asked me that, I would actually either suggest that they don't do it, or if they insist on doing it, I would recommend that they use string inverters. Micro inverters, not strings. Because typically string inverters do not perform well on a north face. Because the amount of exposure you get versus the course of the year, the amount of time over the year that you'll make any decent amount of power is too small.
And what's the implication on the inverter then? Why not a string inverter?
Because I'll put it this way: on a string inverter, usually when you have a north face roof, we don't make one string per MPPT. You have more than one string per MPPT, right? So what will happen now is I tie that north string into an MPPT with strings facing other directions. I'm just going to drag down the entire MPPT.
If you don't have enough MPP trackers, that's the fault, exactly.
What?
That's what you not do.
Inverter. I would have a second inverter.
You could. I know. This is the reason I said that the tool is limited in what it can offer you. You also have to remember a string design tool is not a system design tool. There's a difference. You are designing the strings going to one inverter. I have no visibility or any way of suggesting what you're going to do with the inverter beside this. So it's a string inverter design tool, not a system design tool. So you have to make a difference there, all right? And again, oftentimes you'll also find people, they'll come to you and say, oh, you know what, I got my engineer to do this. He did a helioscope simulation and said, this is going to give me 5 gigawatts of production in the next 3 months, okay? So if I see claims like that, I usually say GIGO. Have you heard the phrase, GIGO? GIGO, G-I-G-O. No? Okay, if you've ever taken any classes on coding, the first thing they teach you is GIGO, which basically means garbage in, garbage out, which means that your computer is a tool. You are the person with the brains. What you plug into the computer decides what the computer is going to give you. You put garbage in, it'll give you garbage out. That didn't mean the computer gave you garbage. You just didn't know what you were doing. Okay? So anytime you use any sort of simulation or calculation tool, you have to make sure that you understand there are some basic assumptions that the tool or the calculator makes. There are some basic assumptions that you make. You want to always make sure that the assumptions you make and the tool make are not at odds. Okay? If they are, whatever comes out of that is complete garbage. Okay? And so once you put all of those numbers in there, it'll give you this sort of a table. This table is a table of suggested designs. And again, just because you see a design on the suggested table of designs here, that does not mean it is a good or a bad design. You still have to qualify that based off of what knowledge you have from the site. This is kind of coming back to the same thing. Because usually if you've got panels on the north face, I don't know if you've got enough room to make 2 or 3 strings. I've got no way of either justifying, denying, or criticizing that choice. Okay? You need to have that knowledge with you when you make a choice from here. Okay, now optimizers and microinverters produce more power. This is a very common claim. Have you guys heard it? Yeah? Okay, so now kind of coming back to this discussion that we were having earlier, not necessarily with me, we were speaking about oversizing, and we were talking about how you want to keep your oversizing between 1, 1.3, 1.5, right? What exactly is that, and why are we doing this? without the hybrid part in the picture.
Thermal degradation, I guess, heat losses in the summer.
Why are you oversizing? Is it asking?
Why oversizing? Without the hybrid part. So I don't want to keep this with the hybrid.
Just string inverters. I guess because of in the summer, your solar panels that are 405 will not produce 405 watts. They're probably, depending on the amount of heat on the roof, they'll be 360 watts,
Yeah.
370 watts. So that's why we all generally do oversizing.
Okay.
You're not using the full capacity inverter. When are you using the full capacity inverter anyways? You have different arrays, things, you're never using it anyways.
Okay. So how does oversizing help you in that way? Because then you're not no, then you're not using the full capacity of the panel, right?
It's like, buddy, if I'm collecting rainwater,
Mhm.
say off my roof
Yeah.
during the monsoon season, and you got a bigger, one guy's got a bigger, like when it's raining less actually, one person has a bigger reservoir. It's just, it works the same way. You have a bigger reservoir.
See, so you agree with me that you stand to lose. You either stand to lose because you're not using the full capacity of the PV panels if you oversize, or you stand to lose on the inverter because you're not using the inverter's full capacity over the entire course of the year. What? Yes, so you stand to lose in either case, is what I'm trying to say, right? Yeah, so now you agree with me that you actually oversize to achieve certain objectives, which is basically, if I've got, let's assume I've got a 10 kilowatt PV array, okay? And let's assume, I don't know what the latitude here is. Does anybody know what the latitude here is? Latitude.
Latitude's 49 degrees.
49 degrees?
49 parallel.
I'm not from here, so I don't know, all right? Yeah, so now, let's assume that you have a fixed tilt, it's not a tracker, okay? And I've got my 10 kilowatt array at 49 degrees from the horizontal facing due south, so my azimuth is 180. So which day of the year or which times of the day of that particular year can you expect to see 10 kilowatts output from a 10 kilowatt PV?
June 21st or whatever, probably that's a long day.
Exactly, okay? So it would be summer solstice, right? Yeah, and so for every day or every hour outside of noon of that particular day, what would you expect to see in terms of feasible output from a 10 kilowatt array? Is it going to be 10 kilowatts? No? Will it be less? Will it be more?
It's going to be like a little parabola that you showed.
Exactly, okay? And so now what you're doing is you basically designed that array to produce you 10 kilowatts on that one day of the year. And for every other day or every other time outside of that particular time period, you will always produce less than 10 kilowatts, correct? Yeah? And so now let's assume that I do not want to design my system for summer. If I were to design my PV array for that particular condition, it means I design my system for that condition, which is peak production in summer. You with me?
You usually design systems for the person's power, like what their goal, but I don't think you.
No, I know. But there's both sides to this. Okay. First thing is you do not have power over how that person's consumer behavior changes. That's one thing. Second thing is you do not have power to change his roof pitches or azimuths depending on his. Okay. So basically, you're working with whatever we've got. So assuming you do not have any such limitations, were you to build a 10 kilowatt system at the latitude of the place, then only on summer solstice is when you would expect to get whatever you expect to get from that. And even on that day, outside of the noon hours, you will taper off. Okay, so it's just a sinusoid. So which means that if you were to look at the output, or you took a class on solar engineering or something like that, they'll actually teach you that is what we call the sun angle diagram, which means that you will see that parabola or sinusoid or whatever you want to call it is biggest during summer solstice or during summer, and it kind of tapers off over the course of the winter, and not necessarily in the duration of time because your length of day also changes, but also the sun goes down in the horizon, and unless you're a tracker, the angle keeps going low, which means your output also goes low. And for you to make sure that you don't have such a big difference between your peak summer and the lowest winter minimum, you kind of design your system for the condition. This is what I meant by saying you design a system to meet a certain condition. Now, your condition that you put forth was to say that you want to meet your consumer's requirements in terms of his energy consumption, right? That's one requirement. The other requirement is how much roof space does he have, at what angles and what azimuths to meet that requirement. And when you come up with a design, you're kind of trying to meet both of these requirements, so you kind of meet them halfway in the middle. So because it's not likely that you'll meet everything, or maybe you'll meet a lot of them, but not necessarily all of them. And to make up for this is where you tend to oversize them. Because when I oversize it, I know that I've only got a 10 kilowatt inverter. I can never get more than 10 kilowatts to it. But without voiding the warranty, at least on the Fronies equipment, you can connect 15 kilowatts worth of DC on it. Also, I know that even if the device or the PV array was able to give you 15 kilowatts worth of DC, your inverter is only going to make you 10. So you're actually standing to lose 5. But the trade-off is during low sun or where the angles and pitches are inappropriate, you could still potentially extract 10 kilowatts from a 15 kilowatt array, which is why you tend to oversize. Okay? Now keep that in mind. Now use that argument over here with optimizers and microinverters. How does that work here? Because let's assume that you put an optimizer or a microinverter on your roof, same 10 kilowatt array, okay? Except for now, let's assume that I've got 1 kilowatt PV modules, okay? Let's forget the 500s or 600s, and let's assume now that you've got 1 kilowatt worth of PV modules, and maybe you attached a microinverter or an optimizer to it. Now let's also assume that the microinverter or the optimizer is a 1 kilowatt optimizer connected to 1 kilowatt PV array or PV panel, okay? So now you use the same logic that I just sold you on when it came to the string inverter and oversizing the string inverter so that you can still get a fairly decent output during the low sun parts of the year. Would you be able to use that logic here for a microinverter?
For micros, no, but for optimizers, yes, same thing applies because you're still having that.
You still have a string inverter, yeah.
A dumb string inverter.
Exactly, yeah.
Under curve, right?
Yep.
So it's still same applies. Microinverters, you're still doing oversizing. It's just you oversize your panel basically. You're trying to get to a certain size of panel.
Yeah. So now, with that in mind, keep that at the back of your mind, all right? And so you're already oversizing them, correct? Okay. And so which means that even if I were to drop the optimizers out of this picture during the sun hours, which is basically summer, let's assume the system's again designed for peak summer. So were I to drop my optimizers out there, and your PV panel is still capable of giving you 15 kilowatts worth of DC, and I've got a 10 kilowatt inverter, I can still get my 10 kilowatts without the optimizer because I've so much overpowered the system. So now using that argument there, come back to the times of the year when you would actually expect to see any value at all from either an optimizer or a microinverter. Which part of the year would that be?
Never.
No, it would be in winter, or if you've got chandelier roofs. Sorry? Yeah, it could usually be either in fall or in deep winter, okay? Because outside of that, if you were to make a fair comparison between a string inverter and a microinverter, your gross oversizing on the string inverter is actually costing you less than throwing in more electronics, okay? And the more electronics you throw in, the more the failure rate, because electronics will fail. So in the long run, again, talk about the cost of O&M, or basically cost of looking after the system over the course of the 20 years, you will see that you are either cutting it the same, or if any, in terms of upkeep and maintenance, you've got less upkeep and maintenance on a single inverter located in an easier to access place.
I have two sites the same street. One's got string and one's got micro.
Mm-hmm.
And today I was looking to produce the same.
They can. I'm not either arguing or denying or this. See, because at the end of the day, you're the person who built the system. I don't have an insight into the system, right? And I also told you that your device is only as good as how well taught you are to use the device, right? And the third thing is, a lot of people will like to say that two systems are identical. Usually they are not, simply because the geographical location itself will kind of put them into separate places, right? So all I wanted to make the point is that when it comes to a fair comparison between optimizers and string inverters or microinverters, it is not as cut and dry as it's made to seem. Okay, so this is kind of a comparison we did on our Fronies offices, and you will see that microinverters do outperform string inverters in deep winter. Sorry, it would only be in the the parts of the year where you are actually buried under snow. Okay, now another common misconception is module level devices are safer. Are they? Why not?
Electricity is like going to get, you're going to get
But-
fire with 240 volt. You're not going to get killed or same.
Yeah, but you're working at a much lower voltage. You're working with the open circuit voltage of one PV module, which is what, 40, 60 volts at most, and one string's worth of short circuit current, which is one PV panel's worth of short circuit current, right? So shouldn't it be safer? Because you take a string inverter, I've got them strung up in series. I can go up to 1,000 volts DC, or maybe if it's a 1,500 volt inverter, I can get zapped at 1,500 volts. So inherently, should this not be safer?
They're safer when you're installing for the installer.
Yeah.
They are safer.
I'm glad you brought that up, because we oftentimes talk about safety without quantifying what safety means. Safe for who? Safe for the structure, the installer, the homeowner, for the bank, your insurance company? Safe for who?
Well, it can be safer for the homeowner too as well. It can. Then I guess it depends on who installed that.
You could start a fire with 5 volts DC.
Yeah.
Okay, so again, when we talk about safety again, it again is not as black and white. A lot of it gets glossed over. It's very easy to scare people saying, oh, you know, the OSHA came up with this, or the NFPA in the US came up with this, and now that's why they want all axemen to not take an axe to a system which has a rapid shutdown box on it or whatever. So the idea of safety is kind of very nuanced. Safety usually actually came up with safety for, I don't know, like a firefighter. Like, let's assume the roof's on fire, somebody's trying to get through the roof, and they want to use an axe. I don't know who uses an axe anymore, and they don't want for the firefighter to take the axe through a live DC cable, which is why they came up with the rapid shutdown requirement. Except, like here, they basically said that the safety in question, or the safety of the person who's, you know, who only matters here is the fireman, right? What about the safety of people within the house? Because the more and more electronic components you throw on your roof, the greater the risk for human error, because a person, and an actual living person, is going and making those connections. Okay, so I don't know, maybe they had a call and somebody broke up with them and they were making the connection and they forgot to crimp it right, or something like that.
They bought a Chinese connector, they bought a cheap Alibaba Chinese connector and
I won't go there, okay, simply because, I'll explain why I won't go there, because I've seen plenty of mistakes. You could give a tech the best of equipment and they could still screw it up. It's actually more you know, a workmanship thing than anything else, than even the equipment you use. I'm not saying buy cheap equipment, okay? But it'll make things harder if you have good equipment, but you're not really paying attention to what you're doing. So again, when it comes to safety, you have material safety, which is the device itself. Then you've got material safety for the structure, the house, or whatever it goes on to. Then you've got personnel safety, the people building it. Then you've got occupant safety of whatever structure that thing goes on to. And the more and more you know, little components you keep throwing into where the scope for human error keeps going up, all of this plays into that safety, and you have to keep that in mind. So, you know, it's up to you to decide whether you want to make 4 connections at ground level or 46 connections at roof level while swatting, you know, flies around your head or mosquitoes around your head. Okay, now again, this is on the flip side. They'll also tell you, oh, string inverters are super safe for everything. And again, it's not as cut and dry. There's a lot more nuance to it, okay? Oftentimes, the leading cause of fire, this is again not my claim, I just pulled it off one of this thing, is your inverters, electronics, okay? A lot of people assume electronics won't fail. All electronics will fail. It's not a question of if, it's a question of when. And when they fail, how convenient is it? How hazardous is it to replace that or work on it? Okay, so the fewer connections or the fewer failure points you have in harder to reach places, the less hazardous it is going to be for you. That should be a no-brainer. Okay, so it's, you know, you just come up with that. And the more and more connections and connectors you have got, like assume you've got a string of 10 PV modules, you would make basically 10 positives and 10 negative connections. Now I throw in module level rapid shutdown onto it. Now I'm making 10 additional ones because I'm throwing in more electronics there. Now what is the failure rate on that electronics itself? I have no idea. Should I need to now protect each of those little itty-bitty things with surge protective devices on one of them? Probably. Is that going to reduce my cost? I don't know. If it took a huge lightning strike, will they all go up in flames? I don't know. Okay, so this is just to give you an idea as to the increase in problems you could have, the more and more connection points you've got in a system. And again, this isn't to say every connection is like this. It's just that your risk for, you know, bad connections goes up the more connections you've got. This is another one that I really love, is the owner needs to know if their modules have failed. Now, let's assume that you've got a PV system put in place and you're an installer with 15 or 20 years worth of experience. What is the component of your PV system that's the least likely to fail? It is, okay? Yeah, and exactly. And we just spoke about oversizing, right? And I already told you that you are grossly oversizing the system by putting a 15 kilowatt array on a 10 kilowatt inverter. So even if your system is working at suboptimal capacity, let's assume at 75% efficiency, except the inverter is still putting out 10 kilowatts. How would you ever find out if it's giving you 75% efficiency or 100% efficiency? Because efficiency basically means I can get you more from whatever it currently is producing, except your inverter is already giving you full tilt 10 kilowatts.
Well, over the course of the year, if you look at your annual data, you'll see that you're having 25% of your panels not producing because your annual production will be down.
Yes and no, yes and no. Okay, the reason being, again, your oversizing will actually mask that for a big part of the, again, I'm not saying this in defense that you should have badly performing panels simply because they're connected to a string inverter. That's not the intention.
If that's what you're doing, then you don't need to oversize if it's masking it. Maybe for like a few
No, the oversizing is what is buying you, like, that clout in masking. In a sense, let's assume you've got a 15 kilowatt array connected to a 10 kilowatt inverter, okay? The 10 kilowatt inverter can only get you 10 kilowatts, okay? So now if I really want to be able to see the situation where the 10 kilowatt inverter isn't actually getting me 10 kilowatts, it would have to be when the PV array is not getting 15 kilowatts worth of light on it.
Or you just analyze a full month's worth of data and you'll see that it's down 25% versus the previous year in that month.
So it's not 4 months worth of data because now you need the previous year's data as well, right?
Yeah, of course. But
Yeah.
I mean, over time,
Yeah.
you'll have data and you know where you should be with your 15 kilowatts DC, because if you're down 25% DC, you'll see it in your monthly production.
Yeah, so there's different ways to do that. Like, for example, if you've already got 2 or 3 years worth of data and you're seeing a difference in production, you already know that. You don't need more electronics, more expensive electronics to tell you that, right? That's one thing. The second thing is, like, even if you did have a loss in production or whatever, we just spoke about how solar is not maintenance free. You actually have to maintain a system. So there are, checks and balances you should be doing at least in spring of every year before the system goes into production to actually be able to find this. And one of the easiest way to find that out is basically inspect your string fuses if you have string fuses, or better yet, if you've got a DC clamp meter, turn the DC switch off, put them all as a short, again, assuming strings are all of the same open circuit voltage, and then you clamp each of those. You'll find out right away. The idea being you can still find out whatever is being sold, but whatever is being sold to you right now is being sold to you as a means of convenience, saying that the homeowner can do this. But believe me, if a homeowner is doing this, that will set off red flags for me, because usually homeowners are not well informed enough to make these claims, because I've been down that path myself. Because a lot of homeowners, I mean, I don't want to sound rude, but they're not well informed enough, like an installer or an electrician, to know one good system from another, because it's the only system they're exposed to. And even that system, usually they're not technically aware enough to know how to go about it, which is also one of the reasons that one of the things that I like to include during that training course I was telling you about is to train installers to wean customers off of them and onto their own ownership. In the sense, let's assume you built a system for somebody and you told them that you look after the system for 2 years, okay? But after 2 years, what happens to the system? So what I like to do is, in the course of the 2 years, I like to get the end homeowner involved in looking at the system initially, so they get to see what you are seeing, and they get to learn from your experience. So that way they don't make wild assumptions and go onto Wikipedia and find crazy things on there and then come and start fighting with you about it. But it's actually fairly common. Okay, so yeah.
Sorry, go back to your question then. Like, if as an installer, how do you know which module exactly failed?
You won't know which module failed, but you will know there is a problem. And when you do know there is a problem, to approach that, to find out which is your module that has failed, there's different ways to do it. You can use, I don't know, like a heat gun to find out what temperature it's running at. Maybe you have a few hot spots or something like that. But so it's basically about troubleshooting. So like, let's assume you've got 4 strings in parallel, okay? And you suspect that maybe one string is fair. The string could have open-circuited, it could have short-circuited. If it's open-circuited, then basically you know that you've lost one string effectively. If it's short-circuited, when you've got them in parallel, you'll see a good portion of the parallel strings are sending their current on the bad string instead of into the inverter. So if you have a DC clamp meter and you see there is current in the opposite direction in this string versus what is going into the panels, then I know I've got a problem on this string.
We have a question for you. What is annual failure rate for modules? It's probably a good one for you to check with Longi. But so what I've heard module manufacturers say is about 100 to 200 parts per million is annual failure rate on modules. Whereas we've been hearing some, inverter manufacturers, what annual failure rates are on inverters, and it's anywhere from 0 to 2%, right? Or 0.1 to 2%. So annual failure rates on modules are tens of times lower
Yep.
than inverters, and that's probably the biggest argument that you can have.
Exactly.
When you're talking about this specifically,
Yep.
when you're talking to a homeowner about failure rates of modules, it's not what's going to fail.
Exactly. Yeah.
Failure rates of companies are reverse.
Sorry?
Failure rates of companies are worse.
Yeah.
That's a common argument I like to make, saying that why don't you throw in a few extra PV modules, because the failure rate on a PV modules is way lower compared to whatever new electronics you might throw on it. And in the long run, you'll actually stand up making better production even during the sun hours, like in summer as well.
It's actually the electronics that actually fails, not the module itself.
I know. Yeah, it's yeah. No, but even if you say the electronics fail, the component of any solar system that's least likely to fail is the PV module. And if somebody tries to sell you an insurance policy on a PV module, it almost sounds funny to me because that's literally what somebody's trying to say when they say that, you know.
Sun fails, we're all in trouble.
We have bigger problems to worry about in those situations.
The biggest issue I've ever seen on module failure has been in Ontario where some massive delamination happened,
Yeah.
right? But that is visual stuff that you'll see where literally the back sheet hangs off the panels, right?
Yeah.
And that's manufacturer error.
But actually, we had some of those backsheet failures. They were recalled, they were refurbished, they were sent out to the field, and when they got reused again, they failed, not because there was an issue with the panel, because the ESA inspector insisted that they drill holes in the frames of all of the panels. And when they did that, they went through the glue which they had sealed the backsheets with. Yeah. Okay, so this is kind of harking back to the same thing. I'm going to skip this one there. We're talking about a leaf kills the whole string. So again, shading is not as cut and dry. There's a lot more nuance to shading. And of course, you all know the bypass manual, so that's already there. Now, this is basically about service. This is I don't like to call it service. I call it cost of ownership. Okay, cost of ownership. Most people will only look at it as the initial capital cost, but not the long-term cost. You have to factor this into that because if you don't, this is not going to add to the cost of ownership, and it will upset everybody. Now, if you do use component-level devices like going behind each PV panel, they will fail. Like I mentioned, even a string inverter will fail. It's not a question of will they fail. It's about when they fail, how convenient is it to replace it. Your string inverters on the side of the house at ground level, replacement is much easier as opposed to having some up there, because when they do fail or they decide to fail, they all don't check out the same day or the same month or the same year. They'll do it at their own convenience, which means that you've got to disassemble things there, get up there, replace it, put it back, and maybe 6 months later you're back doing that on the neighboring PV module. Okay, and again, anytime you make anything, keep it simple, keep the parts count low. You know your bill of materials, component cost and the count. The lower you keep it, the better for you. Make sure you have as much information about the product. Do not make any assumptions. And again, this isn't limited to Fronius. If you don't know anything about a product, reach out and ask the manufacturer before you make an assumption, because the assumption you make might end up being a very expensive one. And again, this is all basically from the solar industry. So. Skip this. I plan on doing this, except I don't know if you have time. Then that's fine. This was basically just to show you how the monitoring service works. There's a slight difference in this one where you see here in most systems you might have seen, simply because this one has a smart meter and also battery storage, which is why you have the 4 quadrant bubble chart there. But this is for a system that we've got installed in Vienna. Do you have any questions? No? No? So you either got everything or you got nothing.
That was a lot.
A lot of good information.
Thank you.
Luckily, you guys can watch it when your brain feels a little bit less fried, and it'll be on YouTube. So you'll be able to pause.
Just share the link. Yeah, share the link.
I'll send everyone a link.
I think everyone is so scared about solar now, we're all going to stop selling solar.
What? Hey, I was trying to do the opposite, not to scare you.
Fronius and SMA, like Edmonton Oilers in Calgary.
I don't know what to say. Thank you.
Thank you. Good stuff.
Thanks.
I think that concludes it. Thank you everyone for making it out, coming in from Alberta and other parts of the province, and everyone that was presenting from across the country as well. Just a reminder, we're going to head at 5 o'clock to Corner's Pub.
4 o'clock.
4 o'clock.
So like now.
Yeah, so we're going to head over there. If anyone wants to come have a few drinks with us, you're welcome to join us. I don't know if there's some food or not, but you can get some food there as well.
If you guys want It's all the house for us. So, yeah.
I'd like to thank again all our sponsors as well, specifically Heumiles and Longi and Pylon Tech and Fronius and Growwatt. I think I've got them all. So thanks again. Oh, there's goodie bags? Oh, yeah. Everyone can grab a goodie bag. I don't know what's in there. Haseen can talk about it.
Feel free to grab a bag on your way out to the bar. We're going to be at Corners. It's like a 12-minute walk from here. If you want, you can walk there. Drinks are on us. Just scan the QR code, and you'll have the directions for that just on your phone right there. So we made it like easy for you to walk there, walk with us there. So yeah, we'll join us there, and thank you everyone for attending.
Good job, Frankensolar. Thank you.
That is cool. That's fun. I have all of it. Thank you. Thank you. You're welcome.
You have it.
Good.